Inglés. Hablo en inglés. Good morning. I see that our colleagues, instead of teaching the younger people new topics, studies, etc., they teach them to drink and to stay late at night. And so in the morning, they cannot succeed in waking up at the right time. Okay, so we start since we have a program which is very dense, and we start with the second industry panel. So I kindly ask the following people to come up on the on the stage: Gianluca Boiocchi, Nokia; Giacomo Bernini, Nextworks; Maurizio Fodrini, Fibercop; Elvina Gindulina, HPE; Domenico Dichiarante, Open Fiber; Danilo De Donno, Huawei; and Antonio Fresa, Ericsson. So we have 7 people. Who's missing? Okay. Good. Again, good morning. Thank you for being here. I'm very happy to see this distinguished colleague here, also because I have a personal interest, and I will ask you a question later on. But we start as done for the other panel, and I will do for the other panel today, with a question, with a general question, what you are doing and what you propose to do in terms of innovation, with specific reference to what we are doing here in the Restart project. So maybe we can always follow this order here, so that we also know when we are going to speak. And so we start with Gianluca.
Hello, thank you very much for this invitation. Even if it was not really suggested, I brought with me a couple of slides to help me a little bit in the introduction of which is our proposal for innovation in this context. Nokia is an important R&D reality in Italy. Our headquarters is in close to Milan, in Vimercate, where we have what remains of an old telecommunication research center that started from Teletrad and then became Alcatel-Lucent and more recently Nokia. In Vimercate we have... Posso andare avanti con... c'è un telecomando? Okay. 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 In Vimercate we have multiple competencies and around 350 people that are in R&D in 2 big design centers. One, it is related to the optics division, and then there is another one that is mobile network division, and it is the one I'm belonging to. And despite the name, mobile networks, in Vimercate, we are focused not in the access design, so not in the RAN side, but more in the transmission side, in the point-to-point digital microwave radio links. This is an area that increased complexity because while it is true that at the beginning it was considered to be a replacement of the fiber, now it is an actual network element that is part of the backhauling network. Today, more than 50% of the base stations are served by microwave links because they do not have the point of presence of the fiber that makes possible to start the backhauling at the place where the base station is placed. So we are actually contributing and starting the backhauling for 1, 2, 3 hops up to the point where we are dropping the traffic to the optics or to the wireline on the wireline network. Our product in Vimercate is, let's say, based on 2 main subsystems with an indoor unit that we can consider to be a layer 2, layer 3 switch, and then an outdoor unit that we can call radio system, but in our, let's say, application, this is more than a radio system because it includes also the digital elaboration. And we are covering frequencies from 6 to 170 gig in two product segments. One is the traditional frequency up to 42 gig, and then the part in the E-band and D-band 80 and 130 gig. Now, there is a strength in this because considering that traditionally this is a fiber replacement, we do not have, let's say, interoperability problem or interoperability to respect between the interconnection. So we are actually doing our best in order to maximize the throughput, respecting the mask and the spectral efficiency. I'm proposing here three areas where, let's say, we are investing, but I'm sure that we may have a contribution from the academia, and I think this may be a good audience where we can collect potential inputs. I have identified three main pillars. The first one, it is related to the RF part. While it is true that we have our internal innovation, because since the time of Alcatel-Lucent, we have the Bell Labs we are cooperating with and we are working with, and we are contributing in designing our up-down converters moving in direct modulation, moving from baseband to the target frequency. On the other side, I'm sure that from the university that may be opportunity in introducing new structures. I have called here the 3H, the high frequency, high power, high efficiency, and high linearity. This is the three main axes where probably the academia may bring some idea. And another area, it is the packaging, especially in the E-band, where we can maybe find alternative substrates to the traditional one in order to minimize the insertion loss and then getting more system gain in the overall system. Then there is a second pillar that is the one related to the new material. The picture is not maybe more clear. This is a branching filter. So between the active part and the antenna, we have normally filtering system that can be duplexer, can be, let's say, branching, couplers, OMT, whatever. And those are designed with traditional ferromagnetic ceramic filters, let's say, traditional old style, I would call, material. That starts to bring to show a little bit their limits at the time the active parts improved because of the new technology, because of the GaN, because of new structure, improved the power, especially at the low frequencies. So when I'm saying limits, means maybe saturation of the ferromagnetic parts of the ceramics, electromigration in the contact parts. We are working in already with some activities, but new material here can maybe metamaterial or whatever can create an opportunity for an innovation. And I'm sure that putting together the competencies inside the same university from maybe the physics with the material technology, we may identify some new area to move forward. And then we have a big item that is quite, let's say, popular everywhere on the artificial intelligence. Yesterday, we had also important contribution from with respect to the energy saving, but there are other items that I would like to put on the table here as a potential research items. One, it is the failure prediction. So the possibility in anticipate the potential hardware problem that before they broke and create traffic outage, so to intervene a little bit in advance in order with the maintenance. Then there is another item that is the possibility in replacing traditional DSP algorithm with a machine learning driven algorithm. I'm talking about adaptive modulation or adaptive pre-distortion type of algorithm. And in addition, there is also another point related to the classification in the packet manipulation. We are normally classifying using traditional packet inspection fields, so it can be pbits, xbit, the SCP, whatever, MAC address, whatever, but that may be also in special environment in an end-to-end secure encrypted world where the let's say the artificial intelligence may help in classifying packets and consequently properly manage the quality of service. These are more or less the let's say items that maybe I was too long. I'm sorry for that, but thank you.
No, thank you. It was interesting. We can make this an interactive session with you. So if someone has questions, please just raise your hand. So they will happily answer, I think. Please try to stay, to not exceed 4 or 5 minutes so that we have time for a second round. Please, Giacomo.
Yeah, okay, so good morning, everyone. So thanks also for the invitation to this very interesting panel. So
maybe just be specific and just point to one or single
issue.
Yeah.
So just a brief introduction about our company, so about Nextworks. We are an SME based in Pisa. So the company is more or less 20 years old. And so since the beginning, the company was very active into the ICT and telco sector. I'm representing here the R&D group of the company, and we have a kind of long track record of participation to research and innovation activities in general in Europe and also in national programs like Restarts. And we are now, let's say, try to push different research directions. Our focus, if you remember also the presentation that I did yesterday on the Grand Challenge 10, is mostly focusing on management and orchestration aspects of mobile networks. And so nowadays, in the kind of evolution from 5G to 5G Advanced to future 6G networks, there are different topics that we are, let's say, trying to investigate. Some of them were touched yesterday in my presentation, includes network capabilities exposure to facilitate cross-operator interaction, but also exposure of capabilities towards verticals. Also integration of AI into the network with the dualism of AI for network and network for AI, which is a very hot topic in terms of research and innovation nowadays. But what I would like to focus today is something that is pretty much related also to our contribution in one of the Restart projects, and it's in the area of network automation. We know that network automation, and it was also discussed in the other industry panel yesterday from the operators, it's one of the key enablers in this transition also to future networks to address, try to address the complexity of the future networks in terms of multiple technologies to be integrated in different domains from the radio, so from the access domain up to the transport, with all the disaggregation concept also in the optical networks that were pretty much detailed also yesterday in the last session. So bringing and trying to introduce automation, we have seen also with the Grand Challenge 10, is about introducing indeed new workflows, new tools, new mechanisms as part of the management of the network, possibly with the kind of closed loop approach that try to optimize different aspects, possibly at different layers, at the resource level, at the network level, at the service level. So even automation, introducing automation is itself a challenge. On the one way, it's trying to solve some problems. For example, improving performance management, fault prediction. It's something that is critical in the next generation networks. But on the other side, having different goals and different optimization tools and algorithms that run in parallel can bring to instability and bring to some conditions where network behavior can be maybe not out of control, but maybe not reaching an end-to-end optimal status. That's why, for example, we believe that bringing into the loop the integration with network digital twins can be one, let's say, good way and a good innovation to try to assist the automation mechanism to be, for example, pre-validated in a kind of emulation or simulation environments that the network digital twin can provide, basically creating this digital replica of the physical infrastructure and the end-to-end network, allowing indeed to validate and assess optimization solutions before they can go into production. The good thing is that the network digital twin in its concept is not just an emulation, it's a digital replica, a live digital replica of the network, ideally always aligned with the status of the network. That's why it can also improve how new services could be introduced in the market and the effect of new services in the existing, let's say, services already running in the network. This was also briefly touched yesterday in the other industrial panel. And so we believe, and in the there was also a grand challenge presentation related to digital twin yesterday. The digital twin itself, it's not a new concept, because in the domain of Industry 4.0, it's something very well consolidated. In the network domain, I wouldn't say it's unexplored, but it's still at the early phases. Also in the standards, 3GPP, ETSI, they are still at the use case phase, so there are not much standardized solution for that, and that's where, for example, we believe that programs like Restart, the Grand Challenge, and also the Coherent project where we are involved, that specifically targets network digital twin, can provide a significant innovation in the area of network automation, but also energy efficiency and others that can indeed provide good benefits in the overall, let's say, area of management and orchestration. And of course, being a partially, I would say, explored area, it gives also room for good innovations, maybe following also incremental approaches, maybe not targeting the full end-to-end network digital twin, but just covering maybe specific areas, for example, for the RAN, for the automation of the radio network or energy saving in the radio network, that is a key area as well in terms of future study. So that's it from my side.
Thank you, Giacomo.
Okay, thank you.
FiberCop.
Yes, Maurizio Federini, FiberCop. I will try to be quite short. I'm working in the Innovation and Engineering Department of FiberCop. You know, we are one of the big player of network infrastructure. And in particular, I involved in the evolution of network architecture and the management system of the network. Our main focus on innovation, we heard already today and also yesterday, the main driver is digitalization of the network and automation of the network, because we think that this type of innovation will provide a very high level of programmability and flexibility on the network. And this allows to significantly reduce the OPEX and can also enable optimization on your investment. In that direction, we think that the framework of network digital twin is the fundamental enabler to allows for this flexibility and for this programmability and autonomous networks. Yesterday, we heard some main driver for network digital twin from the presentation of CNIT, and also a very good concept related to programmability and flexibility on the radio access networks. And I think that concept could be very general for any kind of network domain. So when you talk about softwareization, you can address topics like software-defined networking. So to enable software-based controller to control your network infrastructure in a flexible way and in order to optimize your operational works, also enhance your efficiency. When you talk about software, also how you develop the software is really important, and so it's known that the DevOps approach for the software is the best practice, and we think that it's very important because it's allow for a fast delivery on the network, and you can control all the life cycle of your networks, and so you are able to release very good quality softwares in a very limited time to go to the field. Then the overall part of all the system was very well described in Grand Challenge 10, where we are also involved together with the Super project, is the management and orchestration, because it's the only way you can enable the full programmability of your network, and you are also able to enable some very important concept for a network infrastructure. It is the multi-domain, the cross-domain management and multi-tenancy. And we think that only with a very good management and orchestration system you are able to do this. And of course, there is a topic. Yeah.
Do you think that we are really there, that we can see those in the field or not?
We think that we are not still there, but we are moving very fast in that direction. And we think that we need some main concept to truly go in that direction. One is this concept of digital twin. The other one is the standardization. This is a very important part, because the only way you can put together and communicate together different domain and manage also different tenants on your network is to have open interfaces, and the softwareization is for sure an enabler in that direction. So I think that we are quite in that direction. We are still to work on that. And then a last thing.
Is there a real interest from operators in cooperating and in making this work multi-domain?
Yes. So this is an important point. Yeah. I think that since many things are made by operator are similar, probably you can try to ask the operator to concentrate on specific added value business more than the things that could be done the same way from different operator. Yesterday, Telecom Italia talked about service management orchestration, and they say that it will be very good to have open service management orchestration, and we think it's a very good direction, because there are things that you can do, but also other operators can do. So they can put together the effort to go in that direction. And the last thing I want to address, that is a challenge that we bring on the table of the restart, regard one fundamental things of network digital twin, that is the availability of data. Everything in the software, everything in digital needs to be filled by data. Of course, each business have its own data. Okay, fine. But we think that there are data that are common to many stakeholders. Am I referring to the data regarding the territory? So you think about the digital model of the nationwide geographic territory. This type of data can be used from network infrastructure, are used by mobile operators, can be used by fixed operators, can be used by utilities, gas, water, whatever, can be used by regulatory. You know, for example, in the management of limit of electromagnetic field, you have to talk among operators and also with the regulatory. So you need to have common understanding on the territory. But also smart cities, urbanistic, everything. So we think that very important and challenging innovation should be to have an initiative at national level in order to have a common and unified digital modeling of the territory in Italy. I think it's very, very important. And then the future step should be to have a common platform to have access to this type of data. Probably some kind of federated platform.
I think in that case, there would be the right incentive to really do it.
Yeah.
This specific field.
Yeah, exactly. And this go in the direction that we discussed before. Do you think that it's possible already, the multi-domain, cross-domain? This should be
because there is the incentive to do it.
Yeah, exactly.
Okay.
And the last thing is standardization. We think it's really, really important because without standard, we go in a direction that is not the right one.
Okay. Now it's the turn of HP.
Yes. Hello, everyone, and thank you for inviting me here. I represent today the research and innovation team of Hewlett-Packard Enterprise Italiana, private 5G unit. I will be very brief, but anyway, just to say a couple of words about what we are doing. We develop the software. We develop the mobile virtualized 5G core, 4G and 5G core. And this business has some peculiarity. First of all, we serve and we provide the software together, however, with the hardware and all the basically end-to-end components to different various types of businesses. And they are all different. They have different requirements for connectivity, different requirements for reliability. They have basically all the possible requirements which you can imagine, and they're all different. So it requires from us to have some level of flexibility. Specifically, as one of the first pillar of our business and also of innovation is the modularity of the product, the modularity of the software, of the core, on the mobile core, so that we can afford the distributed architecture which can fit various use cases. Again, this modularity doesn't go together as it is. First of all, it's based on the automatization. So again, I'm going in line with all other speakers before, but automation is really the core of our innovation. And yet there is a lot of work to be done. From our side, it requires from us to be able to expose all the capabilities of the core, of the mobile core, so that with a proper orchestration, the needed required change can be done dynamically, fast, in the milliseconds time. So automation is really the key. And specifically, also thanks to automation, we can leverage and virtual and hardware and the network resources. And they don't go separately from each other. They go all together. And it also helps to trade off the quality of the service, the energy efficiency, and the latency of a network based on the automation. Another pillar of which we are looking at is semantic information. This is something different, which we've been speaking before, and something very new which we are looking at. The semantic information is basically used for taking the intent-based action on the network. Specifically, from the core network, from the radio access network, we can collect all the various types of information, like logs, the data which is extracted by Prometheus, and absolutely various types of data. So what we need to do, we need to semantically represent this data. We need to make it accessible in a human-readable way. And then based on this semantic state representation of the data, we can take some specific action, intent-based action on the network. So we are kind of having a control loop, a closed control loop of the entire system. It is good for multiple purposes. The first purpose is the excuse me, sorry for my voice, I'm losing it. So the first is, first of all, to be able to, thank you very much, to take an action in the thank you very much. First of all, it helps to automate the network in the entire different level. And second of all, we need to have this human readable way of understanding the state of the system, so that first of all, as us, for a provider of a service, we can in a faster way to manage the network. And also for the client, for the business to which we provide the network, we can provide some degrees of a control over the network, which will not require from them a very deep technical knowledge of a networking system. And it's definitely something we are looking at right now. And all of it is based, is impossible without the artificial intelligence engines, which would help to understand all this heterogeneous data. And so AI is again another direction which we are looking at. Specifically, AI is also needed to understand and analyze the data which we are collecting from the 5G core, from the core product. And we would like to also integrate various AI engines in the various parts of the product, and on the level of a network function and also on the level of orchestration, so that we can take an action based on the prediction on this data and to take it a little bit in advance, so that we can provide the lower latency and let's say the faster reaction on the change of a network. And but it is just some part of the research directions we are looking at. We are also now actively participating, as well as Nextworks, in various European and research projects. And one of the topics which is very interesting for us is the terrestrial and non-terrestrial networks. Specifically there, even just practically speaking, we obviously take inspiration from a standardization, from a scientific papers, from everything which the research proposed to us. But then we are going to the practical implementation of the system, and we would like, for instance, implement the distributed system for some specific vertical, for some specific use case. Simply, it's not necessarily going to work. Because if on the physical layer we don't have some required channel capacity, and then just one single link doesn't work, and then always distributed system doesn't work. So basically what we are also missing is some real proof of the concept work to be done on the field for this innovative direction, let's say, in the innovative direction. And terrestrial, non-terrestrial network is one of these really challenging directions which we are looking at, and it's pretty new, and it also goes coherent with the 6G perspective. And I can add more if I have time.
Second time.
Okay. No, because I was also thinking that another aspect which also comes to my head, and is that if you are talking about the 3G or 2G, the standard was implemented almost on 100%. If you are talking about 4G, I don't want to lie about the percentage, but I think it's something like 40–60%. And if talking about 5G, the standard is huge. It contains a lot of possible features which are implemented nowadays, on today's day, only on 20%. So even to understand what is really a feature which really makes a change, which we really need to look at, we need to implement. This is also it's not really a challenge, because it's not really innovation, but it's something we are also working on.
That's interesting.
Yeah.
Thank you. It's also of interest, I think, that the fact that we can cooperate in Restart also towards other projects, towards European projects. So the fact that we have here in the consortium industrial partner, it's good for our academic partners to form new teams to try to get new projects beyond the innovation topics, which is the main one of today. Thank you again. So for Open Fiber, is always automation and data the main driver or not?
Yes, for sure. Hello, I'm Domenico Di Chiarante. I'm in charge of marketing department, and I'm an engineer. So, but I'm working in the marketing department more or less after my graduation in engineering. As you know, Open Fiber is a wholesale-only operator. So we provide the Netflix network and in FTTH network, and in a very low density area we also use FWA services. We are wholesale only, so we provide our services to retail operator that provide the services to end user. We in our product portfolio we have all the stack of the services. So we have from passive network to L2 Ethernet services, and also we provide a direct internet access to virtual fixed operator. So our challenge, I think, would be interesting to analyze is new algorithms and system to predict the internet traffic patterns. Because it could be a very interesting topics to analyze. Because if we remember in the past when we connect internet with dial-up, the revenue of the operator depends of the weather. Because it's rain, if it's rain, the people stay at home to navigate on internet, and the operator, when exists the dial-up, so the end user pay the internet access per use, so the operator increase the revenue, and also the revenue prediction was done also looking the weather forecast. So if we speak now, and what could be interesting for us could be, why don't realize system that can predict the internet traffic also using internal data, because the data and the pattern that we have internal of the network, so the typical traffic, but also predict using external signal. Could be, for example, okay, today we have a live event, a soccer, a football match in Naples area. So that means that in Naples, in the metro network of Naples, we have a very hard increasing of the traffic, because the live streaming is very massive and could increase effectively the internet traffic. Another example could be to optimize the use of network resources and also edge computing resources, because, for example, in the daytime, in working hour, the edge computing hardware could be specialized for the business application, and when we move in the peak hour, typically in the evening, at more or less 8 o'clock p.m., we have an intensity increase of the streaming and playing gaming traffic. So the edge computing and the resources could be specialized to improve the performance of this kind of the services. So for us, the challenge could be introduce and using AI to analyze external signal, so looking on the web, looking on the ticketing system, looking on the social, to analyze where the traffic moving what kind of application, and so also specialize the resources, specialize the network and hardware configuration, and also increase the customer experience, the user experience, in order to provide better services with lower latency, with higher bandwidth. So I think could be a challenge, because honestly we use traffic trend forecast more or less with the standard way. So we analyze what is the pattern that in the past. So we try to analyze what could be the traffic in the next month, in the next year. But I think the challenge could be to find a solution, an algorithm using AI, using machine learning, to provide a very specific forecast also in local city, because live event impact local
We
area.
have colleagues working specifically in this area. Maybe offline we can talk about that.
Yeah. Okay, so this is our challenge.
Thank you. Huawei?
Good morning, everybody. Thank you for the kind invitation. I'm Danilo De Donno from Huawei Technologies Italia. I'm based in Milan. In Segrate, we have this competence center, R&D, specialized on high frequency. That is not just the high frequency that the colleague from Nokia described about millimeter wave backhaul to connect base station to the point of presence of the fiber, but also we have a small group working on 5G millimeter wave, and also the new bands now that we see for the next generation of cellular network, that is the FR3, so upper 6 gigahertz, the upper part of the 6 gigahertz. So when I received the invitation also from Antonio, they asked me to highlight some areas where I see room for innovation. So I think that I couldn't think to something different than millimeter wave, in particular 5G millimeter wave. Because if you go back 10 years ago, I think that it was an hype about millimeter wave. Everyone at early stages of 5G was thinking to 5G millimeter waves to millimeter waves, so these high frequency bands that are, let's say, 26, 28 gigahertz, as the shiny star of 5G. But if you look now at the deployments that we have of 5G, there is nowhere millimeter wave, at least. So we have some deployments in the United States. I can say that there are more than 100,000 base stations working in 5G millimeter wave in the United States. But if you look at the statistics from the US operators, you can see that only 1% of the time of the user is spent on millimeter wave. So you have this massive deployment. How much, sorry? 1%. 1% of the time the user use millimeter wave. And the reason is that the technology is not mature yet, at least for an application scenario like the EMBB, so enhanced mobile broadband, that is the service that everyone uses with the smartphone, let's say. Simply because if the expectation of millimeter wave are to deliver a multi-gigabit per second connectivity, this happens only when you are in line of sight with the base station. And if you deploy millimeter wave in an urban environment, the line of sight is broken very often. So at the end, you come with these statistics. 1% of the time, probably you are in line of sight and you connect to millimeter wave. So I think that we need innovation in this area to make millimeter wave deployable for EMBB. And I see very good projects here in Restart, the one coordinated by Professor Spagnolini, for example, on smart electromagnetic environment, where deploying these nodes like repeaters, RIS, you can enhance the coverage of the millimeter wave, and thus improve the experience of the user connected to millimeter wave. Because I'm not saying that it doesn't work in no line of sight, but if the expectation are to achieve multi-gigabit per second, when you go to no line of sight, works but with several hundred of megabit per second, that is not what do you want from a millimeter wave, because you can achieve the same performance with a lower frequency. And another important point is instead the millimeter wave when they are used for fixed wireless access. I think that here we have in Italy some successful stories with Fastweb that has more than 1,000 base station millimeter wave deployed with providing fixed wireless access. Of course, there it's more easy to identify which homes can be in line of sight with the base station, so you can activate the service to those residential users and provide 1 gigabit, 2 gigabit per second connectivity. But there again, I think that we have a lot of room for innovation, and because, for example, millimeter wave can be used to complement the sub-6 C-band FWA, because in Italy we see that the market on fixed wireless access is on 5G, lower band is growing a lot. And at a certain point, I think that the network will start to be congested, and the operator have two choices: or to stop to serve residential user, to not add more users to the FWA service. Otherwise, you deteriorate the performance of the user that are connected with MBB. Or they can add the millimeter wave layer, so select some houses that can be covered with the millimeter wave line of sight and offload the traffic to them. So I think that we have a lot of room for innovation in this area, because the technology is very promising, but is not mature yet. Thank you.
Thank you. Ericsson?
Okay, good morning everybody. Thank you for the invitation, and my name is Antonio Frisa, and I work in the Research and Development Department of Ericsson. As you know, Ericsson is a big company, and the Research and Development Department in Italy is about 600 people working in 3 different locations. So we are based in Genoa, where there is the headquarters, and main activities are optical networks and network management, and specifically security in network management. Then we have another research center where I work. It's in Pagani, in the Salerno area. And the main activities are security and cloud native networks and core networks. And then we have the global research in Pisa. We work already, we have a lot of cooperations already with the university. We have also a consortium with Salerno and Milan University. I work also in the ADAPT project with Naples and Florence and Pisa, so there are many different cooperations with the university already. But I have tried, together with my colleagues, to identify 3 investigation areas that we believe could be of interest for the cooperation. And one is network operations, the other one is energy efficiency, and the third one is security. The context, of course, is always 5G and beyond networks. And specifically in the area of network operations, the investigation areas that we are more working on are preventive maintenance, network observability and surveillance, and of course the usage of AI for troubleshooting, for network analysis, for automation, as also other colleagues have spoken of this, automation and simplification of network operation with the usage of artificial intelligence. Then in the area of energy efficiency, also we focus on hardware design for optical components, but also energy efficiency in software development, and also cloud native placement and dimensioning. And this is an area where we are already cooperating with Naples, Florence, and Pisa in the ADAPT project. I believe you will see also in the poster the result of our investigations. And then an area that is very important, and it's basically very important for all our products, is the security area. And this means data protection, network protection, and also usage of artificial intelligence for prevention of malicious attacks. And we are also starting working on the post-quantum cryptography, and who knows this matter. I mean, this is a kind of problem that probably will arise in the next years, but it's important to start working on this activity right now to be prepared for the future. That was all. Thank you.
Wonderful. Very quick, very interesting. Thank you. Questions from the audience? Please, Marco.
Well, I was curious about your observations concerning non-light of sight propagations for millimeter waves. How trustworthy you feel that the new technology RIS is, which is these programmable mirrors, which apparently are able to have us look around the corner? Because in the research, it is kind of wonderland. Everybody is talking about these RISs. And I was just wondering how confident industry is about this applicability. Thanks a lot.
To a specific person, Marco, or to everyone? To Danilo. Yes, yes, okay, not the question. The question. Yes, please. Not to everyone. Please. To Huawei.
Yeah,
Please.
I think that it's a promising solution, at least from the research side and from the experimentation, but we have to look at it also when you go in the field. And we have to put into the perspective and also as an operator, we have to think as an operator, no? If you want to install these devices, you need to acquire a site, you need to pay some OPEX, some CAPEX, so there is a cost. So the solution is good, but we have to solve some issues related to the deployment in a real network. So because they can also introduce some interference to other operators in the adjacent band, so there are a lot of practical problems that sometimes are not considered in the literature that must to be taken into account if you want to really deploy and industrialize, let's say, the RIS. But the concept that is using this type of devices or repeaters is the direction where we have to look at if we want to make a millimeter wave more deployable. Yeah.
Do we have 10 minutes tolerance? We started 15 minutes later, so we have 10 minutes tolerance. You are gaining 5 minutes. So please, a very telegraphic answer. I have a rather general question, and I know you have specific roles in your company, so it might not be easy to answer. But thinking to vertical and to applications, I feel that there is a gap in the chain, meaning that we have application developers, we have system integrator, and we have you that provide the network from below. But there is something in between, which is not, in my opinion, enough covered, meaning that when you want to deploy and sell a solution, it's not easy to find a company, someone, that implements the process digitalization for a complete solution. I used the example of the subway of Rome, which is currently being covered with 5G, and which is going to be inaugurated on the 10th of February, the A line. So they are going to provide connectivity, but that is all. So they're not providing, for instance, train maintenance or security or traffic mobility control. But mainly is one of the main reasons is that there is not someone who is going to do that. And the Comune di Roma, the municipality, is asking me who can do that. Because if we go to system integrator, if we go to, I don't make names, but if we go to system integrator, they say that they cannot arrive till the network. If we ask you, you say, well, we provide the network, so we did our job. But who can provide this missing gap? Very quickly, in your opinion, if you know. Nokia? Do you think that a vendor can go up and try to interface first the interface. We know the work on interface, but more than interface.
I think that there are two dimensions. Okay, I'm speaking from an equipment manufacturer. There are two dimensions. One is the interface, as you said. I don't know if NetConf, Young, whatever may help. And this is, and then there is also another dimension that is, according to me, connected also to the story of the, let's say, artificial intelligence, machine learning. That is the type of data to be provided. And this is probably also another level of cooperation where we have to work together with the system integrator, as you say, or with the final users, because at the moment we are coming from a world where we were considering to provide performance monitoring. Okay, so there were statistics that are related to the physical layer. Probably we need to increase our the information to be then provided to the upper layers. And we have this possibility, because I think that at hardware level we have multiple dimensions to explore.
Thank you. I mean, not everybody has to answer, so.
Yes, you said interface, but let's call it API. The APIs are not yet there, so this is the first gap to cover. There is this Open Gateway, Camara, initiative, and only few operators are exposing APIs. Application developers and application providers for whatever vertical, connected or automotive, connected cars, whatever, need to interact with the network. This is something that is very complicated right now, and refers also to the data aspect, because you don't just need APIs to do something on the network, but also you need to understand what you can do, and have data to understand what the application can do. In terms of how to fill the gap from more an operational perspective, in the European framework, there are initiatives to create these platforms for facilitating the onboarding of applications into testbeds, not maybe in production networks, but at least I think we miss these generic frameworks and guidelines on how to onboard applications to the network and to the operators. This is something that it's not standardized, at least as far as I know, and so for me the problem is two aspects: APIs, and have them widely adopted and exposed by operators, and the second is have common practices, maybe through specific APIs, to onboard applications and help application providers to use the network, but it's still not there.
Yeah, I'm quite in line with what's already said. Just to add that when you want to provide a service, you need first of all an operator that wants to provide that service. And then the operator has some needs in order to satisfy all the requirements he needs to provide that services. And these needs depends on the service provided by the network infrastructure, depend on the service provided by the system integrator, and something like that. So there is no, to me, one fits all solution from one side of the part. Yeah, this is the issue. Yeah, exactly. The point is that there should be a collaboration in terms of proposal of services and on possibility to merge in some way, merge in terms of sharing. It's cost and responsibility, because many times the service is not provided because it's not clear which is the responsibility of the enter-China, or I do my piece, but it's not clear which is my own responsibility on what I propose. And the other side of the cost, because I can provide you a service as a network infrastructure to operator, but the cost I have need to be fine for the other part of the picture. So it's a matter of type of services, of collaboration, responsibility, and cost. It's very huge problem because it's difficult to find the right puzzle of all these spaces.
And also the driver, the customer is going to pay for it.
Yeah, exactly, because the market is really competitive in the direction. But I also think that it's very good to stress the importance of research in terms of functionalities that can be put on place. And on that direction, universities, they are doing a very good job. The problem is that this kind of functionality sometimes are not linked to the reality.
Maybe we should speak for customer cases, not use cases, so that we have in mind which are the main focus.
But standardization, I think it's another point that could be put in place, the things. Yeah.
Okay, I would say that, yeah, okay. Now just to say, it's exactly what we are doing. We are, I mean, at least by the current state of the company, and it's now undergoing through the transformation due to the fact that in past we were the startup, now we are part of the big enterprise. But anyway, at the current state, what we were doing before, we were providing a full end-to-end solution in radio and the core with the hardware on which we also put a virtualization layer and also the software of the core itself. Then what we do, we try to understand the requirements, the needs, what type of the service we need to provide, what would be the throughput we would like to have, what is the latency, what is an architecture, how do you distribute an architecture, what radio will fit, which type of the optimization we need to put, what we need to expose. We also have all the dashboards, we have Grafana, we have, all the clients can look at the traffic load, we can look at the CPU consumption, we can look at basically, I would say this is a standard packet for many verticals. For instance, I'm not going to go through the specific companies because I don't know if I can do that. But anyway, we provide for the energetic, for instance, for the San Giardemiere, for the PPTR use case, for education, some university campus. So, for instance, if the students wanted to, I don't know, not just to have a network, but to see how it reacts, to play with it, let's say, to connect their devices and to extract all the data they could. I would say it's something which we did. It's very resource consumption. It requires a lot of time with only the one specific client and vertical. I see it myself, experience it myself, and yeah, it's something which we are looking how to optimize. Also with the means of AI, with the means of the different business models. It's something which we are undergoing, we are looking at, but I would say, yeah, this is a really huge blast of work.
Just for good, I think the network, we are a network provider, but I think the network must evolve as an open platform that provide elementary block that could combine it in order to provide the services. So the challenge for us is to have a very open network with standard API, with standard block services that could combine it from the system integrator, from the OTT, from everyone to provide the services. I think it would be an opportunity to define new services, to standardize some block, and obviously increase the revenue that we can do.
I can skip this.
Okay, this is not my area of investigation, but I can tell you that for Ericsson this is a very important area, and Ericsson has bought a company specialized in API for this network integration, but Ericsson has also created a new company that is called Aduna, with a number of network operators, also Vodafone, T-Mobile, Deutsche Telekom, and so on and so forth. And they are focusing on network exposure and APIs. So this is a business area that is really important for us. And for sure, we will see a lot of new products in this. Thank you.
Thank you. Very concise, but always very interesting. So thank you a lot. Thank you to the panelists. I don't think we have time for questions. So. let's thank our panelists.
2 secondi. 30. You count up to 30. No, up to 30, and then I'm finished. No, you have seen the difference of the perspective, because when you talk about interface, my answer was related to the equipment interface, and I was exposed in NetConf, young, while on their side they were much, much above. Okay, so this is just to explain this difference. Then I will pass to you also. The other point I want to underline is that I like this opportunity. I think that this goes beyond Restart probably, but this opportunity in meeting the industry together with the academia, it should be a more standard. But I think that we need this cross-fertilization. I'm talking for Nokia. We are normally used to work with the local university, the one that are around us, the one we have normally contact with. I'm sorry, with the Politecnico, but I'm sure that there are much more excellencies in the other university in Italy, and I think that if we create opportunity in mutually exchanges experience in needs and innovation, it can be beneficial for the overall ecosystem, for the participation to the European projects, to enhance really the competitiveness of the Italian ecosystem. There are other countries where this is institutionally done since a while, and I think that we should copy with pride these good habits. This is just to...
But, we hope to continue to do it with Restart, so let's see. No, it's good. We lead a rebellion. We will not concede the floor. We will stay here all the more.
No, just to say that, yeah, I was talking about higher perspective, but it's so important, the hardware anyway, because, I mean, you can do whatever automation you want, whatever software you write once. Esatto. Like, honestly speaking, just give an example. It's like even yesterday, not yesterday, some days ago, like something went wrong with the server, got rotten, and spent half of a day in the server room just to fix it. And then everything was done, obviously. I mean, it was for like for my own, let's say, jokes and plays, nothing commercial, but anyway, it's very important, the hardware, and to be able to fast manage the faulty situations.
I like your passion, your interest to stay here, and I thank you really a lot. Thank you. Since we have here Fabrizio Cobis, who is our single person in charge of the process, as a literal translation of group, I kindly ask him to come here and to give us a blessing and a few words of in these dire times, just to say some kind words to us. Fabrizio, dici una benedizione e due parole di incoraggiamento per il futuro che ci aspetta.
Benedizione e incoraggiamento non le stai chiedendo alla persona giusta. Buongiorno a tutti, scusate l'interruzione dell'invasione. Buongiorno ovviamente, e ringrazio Nicola e tutti per l'invito a partecipare a questo momento di divulgazione che dimostra, se mai ce ne fosse stato bisogno, il livello altissimo che questo progetto sta dimostrando di conseguire sul piano scientifico, sul piano dei risultati, che è un aspetto fondamentale, insomma, per il Ministero che ha impiegato così tante risorse per il sostegno a questa iniziativa. È certamente una gran soddisfazione registrare che quanto si era previsto, quanto era stato promesso dal punto di vista del conseguimento di risultati di così alto livello si sta concretamente mantenendo, con tutte le difficoltà, con tutte le tempistiche che noi abbiamo. Questo ci deve stimolare ancora di più, perché siamo tutti consapevoli che siamo entrati ormai nell'ultimo anno di vita del programma e adesso dobbiamo ancora di più fare ogni possibile sforzo, perché anche sul piano tecnico, gestionale, amministrativo, finanziario, di utilizzo corretto delle risorse, si dimostri la stessa capacità e la stessa efficacia. Il tema è presente sotto gli occhi di tutti, siamo tutti straordinariamente coinvolti in questo momento su questi aspetti. Non possiamo permetterci di perdere risorse, non possiamo permetterci che a fianco di un livello così alto di raggiungimento di obiettivi scientifici non vi sia lo stesso tipo di efficienza e di efficacia nell'utilizzo delle risorse, nella rendicontazione, in tutti gli aspetti sicuramente faticosi, pesanti, avvilenti in molti casi, ma insomma questo è il terreno su cui giochiamo. Ci siamo dotati, ci stiamo dotando, vi stiamo, come si dice, stalkerando o aggredendo ogni giorno perché tutti questi aspetti siano seguiti, monitorati, controllati e risolti. Abbiamo in programma, come già sapete, per le prossime settimane dei momenti di approfondimento, perché il 2025 sia l'anno in cui insomma, si arrivi in porto in modo tranquillo, in modo regolare, senza affanni, senza pasticci, senza corse inutili, senza correre rischi di dispersione di risorse che vanificherebbero i risultati scientifici così alti che si stanno conseguendo. Per cui richiamo tutti di nuovo alla massima responsabilità, alla massima attenzione, a non rimandare a domani quello che si può fare oggi. Se c'è una spesa sostenuta da mettere sulla piattaforma, la si metta oggi, non la si deve mettere domani o dopodomani, perché poi alla fine contano i numeri. E siamo tutti consapevoli che questi risultati sono grandi importanti, ma c'è chi poi guarda soltanto i numeri e dice che questi progetti stanno all'X% di spesa, che poi non è vero, ma poi il numero è quello che fa la differenza. E quindi dobbiamo essere molto attenti, molto impegnati. Noi lo siamo, purtroppo voi avete esperienza quotidiana di quanto siamo fastidiosi, però insomma, spero che tutti rispondano correttamente. Ne sono convinto perché insomma, nessuno ha interesse a fallire questo appuntamento, però poi dobbiamo sapere che tutti noi, compresi noi, amministrazione, tutti siamo un tassello, un ingranaggino di una macchina molto complicata e tutti noi ci dobbiamo muovere sapendo che ci muoviamo perché gli altri si muovono in questo modo e non essere autosufficienti, autoreferenti e pensare che quello che abbiamo fatto noi ci deve bastare. Per cui comunque io vi ringrazio, vi rinnovo ovviamente il mio apprezzamento perché insomma oggettivamente il livello del vostro impegno scientifico è oggettivo, è sotto gli occhi di tutti e vi ringrazio tutti, ringrazio Nicola, ringrazio il professor Capone, ringrazio Adele Del Bello che sono dietro tutta questa operazione. Non finirà qui, vi posso assicurare che ci sarà vita dopo il PNRR, non pensiate di aver chiuso qui la vostra esperienza, ma con le possibilità che ci vengono offerte dal PON 21-27 per il Mezzogiorno, questi progetti saranno di nuovo coinvolti direttamente, ma avremo modo poi di parlarne e quindi ancora un saluto a tutti, un ringraziamento e di nuovo mi scuso per questa invasione non programmata. Grazie Nicola.
No, nessuna invasione. No, è stato un piacere. Ringraziamo il dottor Cobis sia per essere qui e per quello che ci ha detto. ma io l'ho ringraziato anche ieri indirettamente perché ci ha autorizzato una categoria altre spese, un vasto insieme di cose che possiamo fare, quindi da parte sua ci ha messo nelle condizioni di aumentare ulteriormente la tipologia di spese che possiamo effettuare. Good, let's go back to our program. The next session will be chaired by Vincenzo Mancuso, who is our prodigal son, who has been away so many years and now is back, and we are very happy to have him again in our countries. Thank you.
Thank you very much, Nicola. Thank you very much to everyone to be here. So my name is Vincenzo Mancuso. I have a double affiliation, to be honest. I'm a professor at Università of Palermo, but I'm still with part of my heart in Madrid, where I've been for 15 years in India Networks. So today I have the pleasure to introduce this technical session 5, which is about integrating communication and sensing and also localization. We will have three talks. So I invite the first speaker is Jacopo Pecoraro from University of Padua to come here. And I hope someone can load the slides. The slides are there, okay. Jacopo is a young researcher expert of sensing and localization, so he'll explain us his work in the frame of the RESTART program. So the floor is yours.
Okay, thank you, Vincenzo. So today's talk is about multi-band integrated sensing and communication. So how do I move the slides? Okay. Okay, so go to the next slide. Okay, so this is the scenario we are going to consider. So in integrated sensing and communication, we have a transmitter and a receiver that exchange communication signals. And we are interested in reusing these communication signals to infer some quantities of interest about a target that is present in the environment. So quantities of interest may include the angle of arrival, the delay of the reflections, and also some phase modulations effect that can get us some useful properties of the target. And this is gaining a lot of interest in a lot of communication standards lately, so it's one of the main features that is envisioned for 5G, 6G, sorry, and also Wi-Fi systems. Thank you. And but we focus in this work on a specific aspect of integrated sensing and communication, which is the resolution. So what is the resolution about a sensing system? So what can we infer about targets that may be very closely located in space? So if you think about a scenario like this, where we have two targets that are spaced by a distance delta d, okay, there is a very famous relationship that tells us how close the targets can be, and we can still resolve them as separate targets with our sensing system, okay? And this relation is saying that essentially it's inversely proportional to the signal bandwidth, okay? So the higher the bandwidth that we use, the more we can hope to distinguish targets that are very close. And actually, if our signal bandwidth is enough, what we have is that we see the two targets as two separate peaks in the representation of the channel that we build. But the problem is that this is how the wireless spectrum looks like, right? So we cannot really increase the bandwidth as much as we want, as we typically do in radar systems, in order to get an accurate representation of the environment. We need to deal with the fact that communication systems typically for sensing are narrowband. So even wideband 5G communication systems that have 400 megahertz are still inaccurate for our purposes, okay? So what we really would like to have is gigahertz widebands, and our aim is to overcome this low bandwidth that we have in communication system by combining multiple bands in the spectrum. So we leverage the fact that communication systems are more and more nowadays multi-band, so they operate in different bandwidths. And what we want to do is flexibly leverage these existing multi-band capabilities in order to gain in terms of sensing resolution, and do that with as little overhead as possible, okay? So we want to reduce the impact on communication. The problem is that usually when you have different systems operating in different bands, they are not coherent and synchronized at the clock level. So the problem with that is that when you try to combine the channel representation, so the sensing signals that you have in different systems, you get two mostly problems that are the timing offset and the carrier frequency offset. So you have a mismatch in terms of time representation and also in the carrier frequency that you have at the different systems. And from a sensing perspective, this is actually a problem because what happens is that, let's say we estimate the channel in a band that is denoted with a star there, which occupies a portion of the spectrum. Then we also estimate the channel in the square band there, in another portion of the spectrum. And we try to combine these channel representations into a single one that extends over the full bandwidth. What we have is that we have a phase mismatch due to the timing and the carrier frequency offset. So the two models that we build do not match, so we cannot combine them, okay? So basically it's useless to try to increase the resolution in this way. So this is one of the biggest problems we need to solve. And what about other approaches to multiband sensing? So actually multiband passive sensing like radars, which is what we are trying to do here, is not very much investigated. There are a few works working on active localization. For example, there's Spot5, which is a very famous algorithm in this sense. The problem with these active localization approaches are that on the one hand, they work with typically very close bands in the spectrum, so there are not very wide gaps that are interposed between the bandwidths, and this means that we cannot span over gigahertz wide bands in this way. And moreover, they also exploit some information exchange across the nodes, and this is causing overhead, which we don't like, and also energy consumption, okay? Other approaches that are more recent are based on deep learning for passive sensing, so they try to combine multiple bands exploiting, for example, neural networks, also generative neural networks. The problem with that, which made us discard this approach, is that they are very dataset dependent. And being dataset dependent in this context means you are technology dependent. So your system only works for 5G, LTE, Wi-Fi, or that specific kind of system that you used in your dataset. And you will see later that this is against one of our objectives. So the concept of our system, which we call HISAC, is to leverage some transmitter that operate in multiple different bands. And we use a single multiband receiver. And this multiband receiver is receiving some subbands, so it can estimate the channel in some subbands. Some of them may be coherent in the sense that they may be received from the same transmitter. Some other are not because they are received from other transmitters, okay? So our aim is to combine these partially coherent, partially non-coherent subbands into a single channel representation in order to be more accurate in resolving some close targets. So the algorithm is quite complex and extended, but it can be summarized in this way. So first of all, we leverage that a subset of our subbands are already coherent, so we can combine them right away. We do that by leveraging some compressed sensing. After we have enlarged our initial channel estimation to a wider spectrum, we need to solve the coherency problem, because now all the subbands that we have are belonging to different systems, so they are not synchronized. So for that, we leverage a new phase offsets compensation algorithm, which is exploiting also some prior work from our side. And then once we have a coherent representation of the different channels, we combine them into a single wider band. We cannot achieve the same resolution as with the full band, but we will see it's a midway between the summation of the different spectral portions and the full band. And then there's a final temporal aggregation step that further increases the SNR. So let me focus on the second phase, because I think it's the core, let's say, of the algorithm. Then I have some backup slides in case you're interested in the others. So this phase, we solved it in a two-steps algorithm. So the first one is to accurately initialize the estimates of the timing offset and carrier frequency offset. We found this to be the key of the solution, because if we don't start from an already quite accurate initialization, our estimation will not converge to anything meaningful. So to do that, we leverage some anchor paths. So we assume that in the environment we have static paths that we can use in order to get the first estimate of the timing offset, okay? For example, this may be the line of sight or maybe some reflection on a static object like walls or the ground. And starting from this initialization, we solve an optimization problem like this one, which is a minimization of the measurement error that we get between the two bands extended over the full spectrum, remodulated and phase rotated by the phase offset and carrier frequency offset. So this problem is very complex to solve unless you have a very accurate initialization, which is why we need the first phase. So we also implemented this in practice, thanks to our colleagues at IMDEA Networks in Madrid. And we tested it with different types of targets, so people and also metal cylinders, which were very useful because they get a very clean reflection. And we tried different setups. And our band of reference is the 6 gigahertz band because it's an unlicensed band, it's very useful, and we can experiment there without problems. So I have a few selected results. In this case, we were testing a 5G new radio configuration, so we have an OFDM type signal. We have two completely separate systems, so unsynchronized, that transmit synchronization blocks from 5G new radio. So we have these 50 megahertz signals that are transmitted in the different bands. And so we only estimate the channel in the colored chunks of the spectrum there. And what we want to do is to estimate the channel over the full 1.2 gigahertz band. And you can see that we can do it pretty accurately since in the last plot here we have that our channel impulse response representation matches very closely that of the two green targets that are there. That's the ground truth that we measure with a laser system. And our accuracy is comparable to that of the full band, whereas the contiguous band, which is basically stacking together 8, in this case, 58 megahertz parts of the spectrum, cannot resolve the targets, okay? So we are going beyond just the summation of the different spectral portions. We also have some results with moving people. So this is quite interesting because we are comparing the discrimination of two moving targets that we can have in the environment with what we have in the full band. So we transmit with a full 1.2 gigahertz band, and you can see there we have a range profile over time. So that's the trajectory of the two people basically walking. And what we can see is that by just transmitting 58 megahertz signal per time step and using our algorithm that combines this in multiple bands, we get a comparable resolution in terms of distinction of the two targets. This was quite surprising because with 58 megahertz signal, what you can get is usually more or less 3 meters resolution. So everything that is closer than 3 meters should not be resolvable. But we can see that our targets are resolvable even when they are like 30 centimeters away, which is quite interesting. Another result, which is interesting for us, is a cross-technology test. So here we wanted to see if we can combine different channel representations from Wi-Fi and 5G at millimeter waves, for example. So we were transmitting an OFDM signal and a single carrier signal from 82.11 AY over a very wide band that goes from 59 point something to almost 63 gigahertz. And we observed that with our approach in this way, you can gain a lot over the single 82.11 AY frame. Yeah, both in terms of resolution that you can see on the right, so that's the fraction of times we can correctly resolve all the targets we have in the environment, and also in terms of accuracy, because the mean square error that we get in the ranging is very much improved. Finally, so some concluding remarks. The take-home message is that with this approach, we saw that we can get a variable gain that spans from 3 to 20 times gain in terms of resolution, with respect to using a single band system with the same bandwidth. We don't have additional overhead, so essentially we don't add transmissions to do it, and we can work cross technology, so we are general enough to work with OFDM signals, single carrier signals, or whatever. And our developments that we envision are to scale to wider bands, although this is very challenging, and we saw that from experimental data. and also to study more the impact of the Doppler effect. So here we consider mostly static targets, but we want to also understand really what happens with more complex motion and faster targets in the environment. So this concludes the presentation. Thank you.
I don't know if we have a second mic that we can use here. In any case, we have time for one question. Anyone wants to ask? Please. Let me check if we can use the other mic. One for you.
Very, very interesting work. Let me move back, sorry. Just a question. So, if I understood correctly, the basic assumption you have behind the phase compensation step is that you assume that the channel impulse response you have between the first transmitter and the receiver, second transmitter, receiver is similar, right? So that means the two transmitters must be close. Have you tested what happens? So to what extent this scheme is say still working when we move the transmitter far away?
Yes, that's a very good point, and actually it's let's say the biggest assumption. We observe that it depends mostly, let's say, on what type of targets you are trying to observe. For example, with people which are extended targets and quite complex in terms of propagation, this starts to decay very quickly as soon as you start moving the transmitters far away. It works a bit better with targets with a more regular shape, let's say. But overall, that's one of our investigations right now. So we're trying to take some measurements by spacing more the transmitters and observe when you change the angle of the signal, let's say, to the target, how much you can get in terms of resolution when they are farther away. Yeah. So the answer is no. We didn't try extensively because we were doing it right now. Yeah.
Thank you very much. We should move to the second presenter, but I wanted to ask a quick question. Have you evaluated the cost of all of this? Because there's no complexity in terms of time, but what about energy?
Computational?
Computation,
okay.
Energy, yeah.
Yeah, the computational complexity depends a lot on how much bandwidth you want to use. So it scales with the bandwidth, of course. The larger the bandwidth you want for the final system, so the full bandwidth. But overall, it's, let's say, in terms of energy, it's a computing energy. So, yeah, you would really need to evaluate the computational cost of solving the optimization and so on. But in terms of transmission energy and for the radio, it's basically free.
I see. Thank you very much. So let's thank the speaker again. And let's welcome Daniela Renga from Politecnico Torino. We present the second paper. Unfortunately, I don't have the titles. Can we set up the second presentation? So Daniela is a researcher at Politecnico Torino, and actually I asked about energy because I know that Daniela is working on efficiency and sustainability and energy-related issues. So it was like to link the two presentations. So please, Daniela, tell us what you're doing.
Thank you, Vincenzo. Good morning, everybody. So I am Daniela Renga from Politecnico di Torino, and I'm presenting a work that is carried out in collaboration with various colleagues from Politecnico di Milano within the 6G-YNet project and the ESA-CAGE project. This work is about high-altitude platform stations for joint synthetic aperture radar imaging and RAN offloading. We are aware of the staggering increase of mobile traffic demand that is further bound to increase in the next years, as reported by several projections, as the one from Ericsson that is shown in the picture. And typically, the straightforward solution that might be adopted in radio access networks is densifying these networks by introducing new network nodes. But of course, this entails a huge increase of energy demand with the related operational cost, besides entailing an increase of the investment cost, so capital expenditure for introducing new network nodes, in the network. And finally, there might be also physical and regulatory constraints that might limit the boundless expansion of the radio access network, especially in urban environments. So the idea is to exploit aerial nodes, and in particular high altitude platform stations equipped with a mobile base stations. And since these platforms float at 20 kilometers of altitude, they can provide a very wide coverage over a terrestrial area, and we can exploit the fact that these platforms are fully self-sustainable because they are powered by photovoltaic systems. And also we can exploit the flexibility that comes from the fact that we can redirect the capacity of the base station wherever it is more needed across the covered area. And also notice that these platforms are bound to stay in place for several years, so they have a long-term operation. So the idea is to exploit the base station mounted on these aerial platforms to offload a portion of the traffic from the terrestrial run from some of the base stations, so that the offloaded base stations can be switched off to save energy, and so to save the related operational costs. At the same time, our idea was, okay, we have some infrastructures that is there for communication purposes. Why don't we exploit for additional functionalities in terms of sensing? So there are a number of applications that could benefit from this kind of functionalities, especially for monitoring critical areas that are at geological risk, like, for example, the Campi Flegrei is a very typical example. Other applications are related to monitoring vehicular traffic, to monitor and coordinate disaster responses, monitoring wildlife, especially, for example, to track migration patterns of animals in protected areas, border surveillance, and so a very wide variety of possible applications. In our case, we are considering the technology of synthetic aperture radar that is feasible in this case because basically it exploits the same signal of the base station, so we do not need to add further infrastructures for sensing functionalities, so we can also save capital expenditures, and also we can exploit other advantages of high altitude platform stations in terms of sensing with respect to satellites, because they have a slow movement, they can provide a higher resolutions because they are much lower, for example, with respect also to LEO satellites, and this higher resolution is provided requiring a lower power, and these are further advantage in terms of energy efficiency. And then we can exploit also the shorter revisit time that is very important to provide a finer temporal sampling granularity. So we put together these two functionalities, and our objective is twofold. We want to investigate whether these infrastructures can provide an improvement of the energy efficiency of the terrestrial radio access networks, or rather the sustainability in general, and if we can provide high quality synthetic aperture radar based imaging. Considering our scenarios, we focused on different area types. We picked 2 urban areas, one more representative of the city center, another one more from a residential area, then a suburban area and a rural area. They are characterized by different traffic profiles that are derived from real mobile traffic traces provided by an Italian mobile operator. And then the different area types are also characterized by different features. For example, different fractions of traditional buildings with respect to more modern one, or different fractions of indoor users. Basically, all factors that may impact the channel quality, the path loss, the line of sight. These settings are made according to reasonable assumption. For example, in the city center, we have much more traditional buildings with respect to to a residential area. And also we consider different altitudes at which the hubs can be posed. And of course, as the altitude increases, we can cover a wider areas, so a higher number of base stations that can be served by the hubs mounted base stations. And also we consider the different elevation angles in the different areas based on the positions of the area with respect to the hubs. Focusing on the energy efficiency, in this graph we report the different area types, rural, suburban, urban residential and urban city centers. We report with the blue bar the fraction of traffic that is offloaded from the terrestrial radio access networks. In red, we have the fraction of energy that can be saved thanks to the fact that the offloaded base stations can be deactivated. And in orange, we report the amount of energy that is saved in the different areas. In general, we observe that the energy saving result interesting because we can save up to 60% of energy by just switching off unneeded base stations, thanks to the fact that we offload traffic to the hubs. We also consider the different altitudes, we see that the benefits are relevant even by increasing the hub's altitude. What we can observe, for example, by the blue circles, is that maybe in some cases the fraction of traffic that we offload to the hubs might be very similar, but the savings that we obtain are very different in terms of energy. And this might depend on a number of factors that include the traffic profiles, the traffic shapes, the base station density, and also how the traffic is distributed among the base stations. Indeed, typically when we have a higher altitude, we can serve a larger set of base stations, and typically in this higher number of base stations, it is more likely that we find the low-loaded base stations that can be deactivated. And since the low-loaded base stations based on the power consumption models that are typically adopted for the base station are also the least energy efficiency, we can save more energy if you have the possibility to switch a higher number of low-loaded base stations. And this is what happened when we, for example, increase the altitude. Another observation that goes also in this direction is the fact that, for example, in the suburban area, we observe the best performance at different altitude. And this, again, is due to the fact that in a suburban area, we have several base stations, but typically they are relatively low-loaded. And this is different with respect to the urban city center, in which we have a high number of base stations, but there is a huge fraction of base stations that are highly loaded, the one that provide the capacity for a very, very dense area where we typically have a high demand. Then, regarding the sensing, we want to observe if we can provide a good quality functionalities in this, to this extent. So we consider the effective isotropic radiated power that is reported on the x-axis to evaluate the bit error rate on the left y-axis reported in blue, and on the right y-axis reported in orange, the noise equivalent sigma 0 that basically gives an indirect measurement of the noise in a SAR imaging. So we want to have a low value of these metrics to have a good quality of the image. The elevation angle considered in this case is 50 degrees, is just one possible elevation angle that we have tested, but basically represents also a pessimistic case, so just to see the worst case, like in a rural area in which the elevation angle is lower. What we observe is that at different altitudes, represented by the two different curves, dotted and continuous, in general, in terms of bit error rate, increasing the effective isotropic radiated power allows to decrease, of course, the bit error rate, and especially there is a higher benefit at lower altitude. In terms of, let's say, quality of the image, we see that for any power setting, we can achieve a good image quality, but for example, considering higher values of effective isotropic radiated power, like 45 dBm, that is actually the settings that we are using for the simulations from the communication point of view, we achieve high quality sensitiveness. So basically, under all the test setting, we can say that we can provide a good imaging sensitivity for proper target detection using synthetic aperture radar on top of this communication infrastructure installed on a HAPS. Finally, to broaden the investigation about sustainability, we investigate how hubs can reduce the RAN carbon footprint. We considered both operational carbon emissions due to the operation of the base stations, to the fact that we can save, that we consume some energy, and the embodied carbon emissions related to the fact that we are related to the manufacturing, transportation, and end-of-life management of the base stations. The light colors represent the baseline case in which we are not using hubs. And the other one represents the case in which we are using the apps. Clearly, we see that the operational carbon emissions are, of course, reduced in all cases and can be more than halved. In this work, we are not considering yet the impact in terms of embodied carbon emission, but this is one of our future work, because basically the fact that we are switching on and off the base station, so the switching operations, and the fact that base stations can be put in sleep modes have an impact in terms of increasing or decreasing the base station failure rate, so have an impact on the on the base station lifetime. So if we can improve through by switching off base stations, putting them in sleep mode, if we can increase the base station lifetime, of course the embodied carbon emissions can also be reduced thanks to this approach. And this will be investigated as future work. So to conclude, let's say that these results highlights the effectiveness of using a hubs-mounted base station to improve the RAN energy efficiency with up to 60% of energy saving, and also to reduce the carbon footprint. And we have seen that the operational carbon emissions can be up to halved. Regarding the sensing functionalities, we can ensure high quality SAR image. Of course, a very relevant aspect that we need to investigate as a next step is a trade-off between communication and sensing performance, in the sense that we may need to split our available bandwidth to provide simultaneously different cells from the apps-mounted base stations to cover simultaneously different area types. Of course, this might be beneficial from a communication point of view, because we can serve different areas, and we have seen that it is sufficient to provide a small capacity with respect to the traffic demand of the terrestrial base station to have relevant benefits in terms of energy saving. But at the same time, if we split the bandwidth in different cells, from the sensing point of view, we might impair the quality of the images. So we must identify the proper trade-off to enable the coexistence of these two functionalities. And then another important aspect that we are going to investigate is the relationship between the energy efficiency potential and the characteristics of the different areas in terms of traffic profiles, load distribution, base station density, also because these for sure impact the potential of energy efficiency. The third point is the one that I have already mentioned about the impact on embodied carbon footprint. And we have some preliminary results about the investigations on the impact of the different characteristics of traffic. I do not have time to go into the detail, but basically we have observed that if we consider the same settings of spectral efficiency and the same number of base stations in all the areas, meaning that we assume that we can provide the same actual capacity to all the area types with the same number of base stations, the areas that features the higher energy savings are those like the suburban areas that we observed having the highest energy saving, but basically they are characterized by the lowest average traffic per base station, confirming the intuition that we had about the fact that it is more effective, a similar approach, when we have a lot of base stations that are not energy efficient because on average they are carrying low traffic. So this concludes my presentation. Thank you for your attention.
Thank you very much, Daniela. We have time for one or two questions, quick questions. Anyone? Otherwise, I can start with a question which is not really technical from the point of view of what you have shown, but as a curiosity. I mean, what you can do with hubs, can you really replace the network of base stations or integrate that? Because hubs are not going to have exactly the same capacity. They are going to suffer turbulence, the effect of wind or even the sun will affect them. So how do you see that?
Yeah, well, there is one aspect related to the self-sustainability of hubs that, of course, they can be assumed fully self-sustainable, but since they rely, of course, on solar panels, there might be some service discontinuity at some point, so it might be a problem to provide connectivity just using apps. But also, there is a huge potential for apps as nodes that can integrate the hubs, the RAN. I see more their potential to integrate the terrestrial radio access networks because also to exploit the flexibility of having capacity that can be flexibly redirected whenever needed. So to serve peaks of demand, to serve remote regions that cannot be served by well-deployed infrastructure. So I would see them more as an additional integration.
I tend to agree. Thank you very much. If there are no other questions, let's take the speaker again and let's move to the last presentation.
Thank you.
Thanks, Anila. So the third and last presentation of the day is going to be delivered by Luca Denardis, from professor at La Sapienza University of Rome, expert of IoT, indoor positioning, and cognitive radio, many other things. So today, Luca, please tell us what you have, how you have used the money of this project. This is the reason why we are all here together.
Yeah, we're trying to use as much money as we can. So, okay, thank you, Vincenza, and good morning, everybody. So the aim of this presentation is to tell you, to show you the latest results that we got in one of the activities that we are carrying out in the framework of the Structures Project 9 on industrial networks. And in particular, this activity is aiming to explore the use of machine learning for positioning in 3GPP networks. And we decided to have let's say, an experimental approach. So we rely on experimental data that we collected, and as I will say, will tell you later. And this means that we are, for now, only working with the UE-based approach, because we don't have any information on the network side. We are trying to work with partners in Restart to get some information on the network side, for example, for private networks. And of course, since we are working with commercial data, we would like to take into account the limitations that we see in the data that we can extract from commercial networks. For 5G, this means typically release 15 data. But actually, even if I will be mostly talking about 5G, this activity started a few years ago with the different technologies. So there was a first phase that started in 2021 where we focused mostly on narrowband IoT. And then in time, we combined or compared narrowband IoT and 5G. And now we are mostly focusing on 5G and maybe in the future beyond 5G. And this activity is part of a large collaboration with the University of Karlstad, University of Oslo, and Rode Schwarz, with which we have an agreement for using their equipment for testing and measurements. And actually, our experimental setup is centered on the mobile network scanner, the TSM-A6 provided by Rode Schwarz. So here you have the setup, you have the scanner that collects passive data on downlink signals, but you can also at the same time perform active tests, for example, throughput, interactivity, delay, and so on. In this presentation, I will mostly focus on passive data collected from the scanner. And with several configurations of this setup, we performed multiple campaigns in the last 5 years, I would say. In this work, I will be mostly talking about data that we collected in Rome in 2021 for 3 technologies, and then again in 2023, focusing in particular on 5G. But of course, we have a no-standalone deployment, so we also collect 4G data by default. Now, the way we use the data is to collect them. The scanner has a geotagging feature, of course, with the GPS antenna. So we organize the data like this. We have collection points, and as you can see, this is 2023 data. We have, for example, about 33,000 points. For each point, we have a table with the actual data. And here you can see, of course, the main RF indicators, RSSI, SINR, RSRQ, and RSRP. We also have time-related information. This is not exactly a propagation delay, but you can extract propagation delay from this information to some extent. And most importantly, each entry is associated to a combination of 4 indicators, which are PCI, beam, frequency, and operator. And for us, this combination is the unique label for that feature, and we call this unique PCI. The baseline approach with which we use this data is based on fingerprinting with WKNN. This is also because we come from indoor positioning using Wi-Fi, where this is the default, de facto standard. So I will just tell very quickly how WKNN works. Many of you will already know this. So in WKNN, you have first an offline phase, which is a training or calibration phase, where you build a data set with a set of training or reference points, and you build a matrix where you have a number of columns, a number of rows, which is the number of reference points, and a number of columns, which is the number of unique features that you overall detected in the area that you're covering. So the IL point in the matrix contains the value of the health feature measured at the height reference points. Of course, not all features are detected in all points. So for points where entries where we have no data, we have a reference value. Once you have this data set, you simply perform the estimation or the inference phase by asking the device in an unknown position to collect the same data. You structure the data in a vector, and then you pick the k rows in the training matrix for which you have the minimum distance according to some metric that you have to define. And the corresponding k points are used to estimate the position of the target point. So we are relying on the spatial correlation between the measurements and the position where you collected the measurements. And in our case, the metric is simply a modified version of the Euclidean distance. The modification consists in the fact that we are weighting the Euclidean distance over the whole set of features by the number of features that were actually detected in common between the 2 points. Now, with this approach, we started to work with this approach, and the first question one might ask is, okay, why do you use fingerprinting? Because the default solution for positioning into GPP networks is actually time-based. It's, for example, OTDOA. Well, the reason is that you have to manage to use the data that you have. Now, if you have very good or reasonably good distance estimation based on ranging and on time information, you can perform a time-based positioning. But if your error in the time of arrival estimation is large, this doesn't work. And unfortunately, at least from the way we can process the time information, the error that we observed was rather large. For example, this is a PCI where we had 52 meters of average error. So this is too large to do time-based positioning with commercial networks right now. At least the way we process data, we are open to discuss this. Maybe somebody has a better way to do that. So we moved to fingerprinting. And the first thing that we did with the 2021 data, where we had multiple technologies, is to compare the accuracy that we get with this approach with multiple technologies. The nice thing about the scanner is that you are collecting data for all the technologies at the same time and at the same position. So this really helps in having a direct comparison. And here you have a comparison with 3 technologies for the 3 operators that in 2021 Rome use both narrowband IoT, LTE, and 5G. And as you can see, actually, what is really important here is network density. In 2021 in Rome, LTE was by far the technology that has the richest coverage. So this is the technology that for all the operators led to the lowest error. We are in the order of 8 to 10 meters, depending if you combine the data from multiple operators or if you take a single operator. But beyond that, it's also interesting to see how the different network design choices by the different operators affect this approach, because here for one operator you see that actually 5G is the worst technology, and this is mostly because this operator does not use beamforming in Rome in 5G. So this means that the number of features that for us are also determined by the beam are much lower in number compared to the other operators, while for the other operators you have beamforming. So in this case the density that you get in 5G is multiplied by the number of beams that an operator is using, and even if you don't get down to what you get with LTE, you get reasonable performance. Now, after we analyzed the comparison between technologies, we understood that we needed more data to better understand how 5G works. So in the next collection phase, we focused on outdoor locations. Here there are the 4 outdoor locations where we collected most of the data. And if we focus in particular on one location, hopefully yes, that is characterized by, I would say, 3.2 million points. This is the 33,000 points I was mentioning before. And the reason why we focused on this is that this location was also used in 2021. So we had a way to directly compare how things changed in terms of positioning as the deployment of 5G progressed from 2021 to 2023. So the first comparison was actually to understand how the network changed. So this is the number of features for the operators that were detected with 5G in 2021 and 2023. And as you can see, for 3 operators out of 4, there was a dramatic increase in the number of features. This is because these operators moved in 2 years from a single frequency deployment to multiple frequency deployments. There were more PCIs because the network was denser. There was also more aggressive use of beamforming. So overall, this translated, especially for this operator, in an increase in positioning accuracy, because we understood that network density was the key issue here. The only exception is one operator that stayed with no beamforming, and there was only an increase in the PCI, so the overall number of features changed, but not so much. So also the performance increase was more limited. And of course, you get a larger increase if you use a metric like RSSI, which is more affected by noise. If you use a metric like SINR, which is already cleaner, the gain that you get is smaller because you have less noise to counteract in this case. In this comparison, we wanted to be fair, so we limited the data that we used from 2023 to the same number of points that we had in 2021, which was rather limited, was 2,300 points. But then we focused on 2023 data, and here we could use the old data set. And here you see just an example of the results. Here you see, we tried also to understand what was the impact of the quality of the collection phase. So points that were collected at low speed, according to GPS data, would lead to a better accuracy in the order of 4 meters. Points with that were collected in points where the driving run was at higher speed had a larger error. But overall, the accuracy is rather good. It's in the order of 5 meters. That's why we talk about GNSS grade. We are more or less in that ballpark. But the issue is that WKN is a heavy algorithm, especially if you want to use many points or if you want to have a high rate of positioning requests. So the next question was, can we keep the same accuracy and reduce the complexity? And we try to do this with two different approaches. The first one, that is the one that I'm mostly talking about today, which is the combination of clustering and WKN, and then a full DLNN approach that I will briefly mention in the end. So for clustering, the first approach was really simple. We tried with hard clustering. The idea was I divide my points in clusters, I perform a clustering decision, I associate the target point to one cluster, and I perform WKN in the cluster. This doesn't work very well because you have a lot of issues with boundaries, because if a point is at the boundary between two clusters, you are never getting the right set of points to do WKN, and also the clusters were rather uneven. And in the end, we decided to move to soft clustering. The main difference here is that when you have a clustering decision, you are not deciding, okay, this point belongs to this cluster, but you have a membership vector. You have a vector where you have an entry for each cluster, which tells you what is somehow the probability that the point falls in that cluster. And the way we use this information is as follows. I just give you an example. Here in red, you have the test points. You have a target. The first thing that you do is to perform a course estimation, and you do this by taking the clustering decision, and you take the entries of the membership vector and you use them as weights to perform a weighted average of the position of the centroids of the different clusters. But this is just a coarse position estimation, and we use this to determine an area which is set by a radius around this coarse estimation, and we only keep the points around this point in this area. With these points, we perform WKN to get a fine estimation of the position. There are a few trade-offs in this approach. They are mostly dealing with the number of clusters and the selection of the radius for the domain definition. If you keep them low, you will reduce the complexity more and more. And on the other hand, if you increase them, to some extent, you will gain in accuracy. There is a limit where if you keep increasing them, you're actually starting losing accuracy, but there is a soft spot there. And this also depends, the trade-off between the complexity and accuracy also depends on how you take the clustering decision. We tested a couple of alternatives. The first one was also determined by the limit in the platform we were using. It was based on random forest. Here the idea was to train a single random forest model for each cluster, to take a regression decision on each cluster, and we'd use, for example, if you had 10 clusters, the 10 values would be normalized to become a membership vector, and then we would use this for the course estimation. Later, we moved to a custom neural network that takes a single classification decision, and actually this is way lighter in terms of complexity, but it's also better in terms of accuracy, and we see this from the fact that if we use this, we can reduce the radius for the domain definition, because we are typically closer to the actual position of the point. So when you design your system, you can be more aggressive in cutting points from the final estimation. And what we got is something like this. If you use WKN on the whole data set, where, as I said, we are slightly below 5 meters. If you use this approach with the second approach for classification, you get 4.8 meters. So we kept almost all the accuracy. And actually, it's very hard to go below this. So our assumption for now is that we are hitting a wall related to the ground truth, because we have GPS error in our, or GNSS error in our ground truth. And we saw that in some cases where we had a bias in the information provided by the GPS, our estimation based on fingerprinting was much better than the original one. So we know that the ground truth is affected by error. And this brings me to the next steps, to the work in progress. The first one, as I said, is to complete the analysis with a full DLNN architecture. And here the early results are very good. We are getting more or less the same accuracy, but the complexity is, of course, going further down. We want to explore the combination of multiple features. For now, combining the 4 features didn't bring a significant advantage, mostly because they are very correlated. But we hope and we think that using time of arrival information, even if it's not good enough for time-based positioning, could provide additional information for fingerprinting. And we want to work with a more reliable ground truth, because we would like to test the limit of the accuracy that we can get when we have accurate ground truth. And this will be easier when we will move, as we are doing right now, to indoor environments. And we are mostly focusing on industrial premises, because this is the core of the activity in the industrial network project. I close my presentation with just some additional information. most of the data that we are using are released under open source licenses, and this may be of interest for many of you that want to do something maybe better or something completely different with the data. So you will have the slides, and here you have the links to all the datasets that we released so far. And of course, we are very happy to contribute to the community, but we also try to make ANVUR happy. So we also published some papers. And here you will have a list, and the papers that are in boldface are those that are mostly related to positioning. Of course, with this data, we are doing many different things, handover, coverage, but these papers are those where I mostly talk about positioning. Okay, this is it. Thank you very much.
Thank you very much. Nice talk. We have time for a quick question, and then we have the coffee break. So I think I wanted to ask a simple thing. This is very nice. The results are very good. But what happens when the fingerprint changes? I mean, you have a sudden change, and then you have to react.
Okay, so yes, this is a very good question. Actually, we are trying to explore this because, of course, these campaigns take time. So the campaign that we took in 2023 was taking over 6 weeks. So right now, we are still using all the data, but we are also starting to split the data in different periods to see if we see any effect about the time, and or maybe also the day where you took the measurements. And actually, this is now possible because we have plenty of data, because we already understood that if we cut down the data set to maybe 10–15%, we are keeping the same accuracy. So we can actually split the data and see, for example, what happens if I take the training set now and I use a test set taken 6 weeks later. But yes, this is a very important question, and we are also trying to see how much you can reduce the training phase, because this is a very time and effort consuming, of course.
Thank you very much. So let's thank Luca, but also Jacopo and Daniela, who presented before, and this concludes the session.
Thank you.
Enjoy your coffee.
Thank you. So we are ready to start the industry panel number 3. So if you can take your seats and we can start. Great. So we have the pleasure to have with us Patrizio Pisani, Unidata, Antonio Marsico, NetReply, Enrico Brinciotti, Anritsu, Maria Rosa Pizzo, Italtel, Federico Civerchia, Smarty, e Roberto Candela, Prismian. Welcome. So, like for the other two panels, we would like to start with a round with you, trying to explain what are the innovation needs or innovation directions that you believe are more interesting, and in particular those in which you believe that the research community can somehow help you. And again, the invitation again is to try to identify the topics. We are at the end, of 2 days of presentations and discussions. Understand, and give suggestions maybe also to researchers if the directions that we are taking in research are good or not, or meeting or not your needs. So let's start with Maria Rosa, I'd say.
Thank you, Antonio. Good morning, everyone. Thank you so much for the invitation. I'm Maria Rosa Pizzo. I work in the Fund and Research Project team at Palermo office. The team as part of an innovation entity, which is a part of a global offer line evolution in the company. Italtel is a multinational group that design and develop and implementing a technical solution innovative for large enterprise, for large company and public administration. Many industry that where we are, telco and media, energy, utility and transportation, banking and assurance, leading enterprise and digital health. For focus on the company has embarked on digital transformation journey, focus on specific topic such as cyber and OT security, intelligence artificial, automatics and automation, network evolution and 5G, data center and cloud journey, smart and vertical solution, modern work and digital solutions. With a particular focus on cyber security, the company has developed several skills in advisor services, technical governance, IT and OT security assessment, infrastructure, a business process according to reference standards such as NIST, GSF, and so on. Design, migration, automation of large projects, digital twin, multi-vendor approach, and innovation solution with particular reference to quantum cryptography. Field quantum cryptography is an innovation theme for us to pay attention in telecommunications and industry sectors from now and to the future. The adoption of quantum safe technology is essential for securing telecommunications, networks, and digital infrastructures in the post-quantum era. This is particularly critical in the industrial sector, where the focus on lies safeguarding operation technology systems, implementing this technology through hybrid solutions that integrate traditional and quantum safe approach, offers a practical and cost-effective pathway for incremental upgrades, a gradual and less invasive integration. About quantum cryptography, Italtel, through research activities, has already participated in European projects in the field of quantum safe communication, forming collaboration with international companies that develop the technology in anticipation of the quantum era. The scenario depicted. Company managing high-sensitive data and to protect them from cybernetic attacks are considering the adoption of quantum encryption system before its advent. In the proposed solution was adopted the distributed symmetric key exchange protocol, proven to be immune to both quantum and classical computational attacks. The system is composed of two components, Security Hub and Security Management Entity. The Security Hub orchestrates the generation of secret keys, symmetric keys, between the key management entity, which connect directly to network device via standard ETSI quantum key distribution. Alternatively, the key management entity can be integrated directly into existing equipment as a software module. The solution is secure. Because without having to overhaul your system, protect your data, the data with the most advanced technology. And adapt the system in the project to your need, managing an unlimited several equipment. Quantum safe networks are crucial to protecting digital economy from attack and from now and future cyber threats, especially with advent of quantum computers. Several aspects to consider. Growing cyber threats. The pandemic has increased the frequency of cyber attacks, causing several consequences such as fines, ransom demands, and the loss of customer trust. Significant incidents, such as the ransomware attack, for example, on Royal Mail and the United Kingdom, disrupt international postal service. Increasing cost of breach. The global average cost of the data breach has increased 15%. Threat from quantum computers. Quantum computers pose a serious threat to current cryptography systems, potential making many cryptography methodology obsolete. Implementation of a quantum safe network. It is urgent to implement a quantum safe network to withstand the capability of quantum computing. Another attacks very important, H and DL, harvest now, decrypt later. Attacks pose an immediate threat to business. Advanced security measures. Quantum safe network use robust cryptography methods and a combined strategy to ensure data security. Need for modernization. Network must be modernized towards a multi-layer quantum safe architecture. The issue is also in the industrial sector for the machinery and for the people safety.
Thank you. Quantum cryptography is one of the topics that we have in one of the projects, in particular Rigoletto. And of course, this is one of the areas in which we have actually been working, considering also the scientific results coming from another extended partnership, which is dedicated to quantum computing and quantum communication. So definitely, this is probably one of the most interesting innovation direction that is being considered by the research community.
Yes.
Understanding how to bring these to the market and understand really how to transform these into services. This is another issue, of course.
Yes. This is the direction of a strategy company. Yes.
Mm-hmm. Thank you. Let's continue with Patrizio.
Hi, good morning, and thank you so much for this opportunity. Unidata is a 40 years old telecommunication company. We started as a small company in Rome, and now we are a big company listed in the stock market, and we cover all the nation. I can I want to share with you our vision, moving the vision in a higher level. 30 or 40 years old, the domain border of the telecommunication company was the physical level for voice and data transport. Up to now, the domain border of telecommunication company is in a higher level. And between the physical level and our customer, there are a lot of digital level that we name digital infrastructure. In our vision, we maintain our DNA of the infrastructure company, but a lot of infrastructure are the digital level. And I want to share with you our needs at this level. And just an example, a data lake is a digital infrastructure. And as a service layer in our data center is a digital infrastructure. And I want to explain our vision with a real market case. In the last 2 years, we become a leader in Italy of IoT low power wide area LoRaWAN network. And the market drivers in Italy and in Europe of this market are the water utility companies, because there is a dramatic increase of innovation from the water sector. Now with our Nectar, we can collect data from 1 million of devices. We store this data in our data lake. What we need, we have to transform this historical series of data in new infrastructure and digital service for the water utility, because they want to transform the water network in a smart network data-driven. And what we are doing with our partner of La Sapienza and Università di Palermo is to create a new level of digital service for the water utilities to transform this big amount of data in new service for water leakage, network optimization, prediction, and is a real case just to manage critical situation in which we have a low level of production of availability of water. And the way to obtain this kind of smart grid is to use a data-driven model together with the engineering traditional model of water utilities.
Thank you, very interesting. I mean, we have, you already mentioned, we have already some activities associated to, the network for monitoring natural resources and the distribution of resources like water, and the network that can enable this kind of data gathering is fundamental. Of course, LoRaWAN is one of the solutions. In the other panel, the discussion was, understanding if this is the right solution or there are others. But of course, for you, it's important to provide the service, not really the technology which is used. Thank you. Enrico.
So, good morning again, everyone. Enrico Brinciotti. I oversee for Anritsu engineering, marketing, and business development in EMEA territory, primarily in Europe. My colleague Giulio, you already introduced Anritsu, so just to mention that we are 130 years old this year. So we have, let's say, quite a long track record in the telecommunication sector. So challenges and innovations, I think it's really a key topic right now in this timing. I'm an engineer, so I like to start to define innovation, right? So because we can think of ideas and what ideas means for 5G or beyond 5G. What is an invention? And we have seen many interesting topics addressed in these 2 days. But then innovation is then something else. So what is missing? Well, if very briefly look at 5G, the idea was, okay, can we have an ultra-fast, ultra-reliable, low-latency network? But an idea is not necessarily validated, right, executed. Then the invention comes into place, or the POC, and we have a number of POCs here, where the 5G standard basically was then created. New bands, wide bandwidths, core network flexibility, I can go on. How do we move from proof of concept to proof of business that's where the challenge is, right? And that's where innovation becomes real. I'm not an expert in economy. I'm not an economist, so I'll quote Schumpeter, who defined innovation. It says, it's a successful application of an invention to meet customer need, deliver value at the right time, place, and price. So I think this is where the verticals issues that we are facing today is exactly posing the key challenges, right? So how can we deliver and extract value from, as an industry perspective, of course, I can only speak from an industry perspective, through technology, but to, again, deliver and extract value at the right time, place, and price. And where are the challenges? It's not a seminar, so I can only mention the key ones, at least in the perspective of Amritsu. We are a test and measurement company, so we work across many verticals. So I think we have a privilege, in a sense, to see across verticals where the challenges may be. I think the complexity of the network on the core side, which for sure we achieved POC flexibility. It's clear that on the operator side, there are big challenges to make it scalable, because on the downstreamers, there is no real traction. So that's the number one challenge, which I think in the transition towards 6G, we should definitely look at. So strong focus on keeping the flexibility of the network, but how do we reduce complexity? And I think there are a lot of ideas here. I would stress out, let's not only focus on the outcomes, on the technology, but also in the early stage in the process, because that's transitioning in our mindset from proof of concept to proof of business, right? And this is where cooperation is very important, because obviously the angles of view are different. So early stage collaborations, I think Restart is a perfect example of this. We do believe in that in Amritsu. So Mobile World Congress is behind the corner. We will only showcase solution in partnership with other players. You've seen Tor Vergata will be there, other players. So it's not just about what Amritsu can bring to the market, but what we can do together to solve these challenges. And the other second key issue I see is timing. There is a timing misalignment because of the disruption that we are bringing with 5G, I believe. So we have this 10 years wireless cycle, which until 4G, primarily, you know, the renewal of cell phones was feeding, let's say, this innovation. When we penetrate new industry verticals, there is a time for adopting all these elements, which if we force the 10 years wireless cycle, and we are now looking at 6G, we have to be very careful. So that's where also all the industry standards are focusing right now, stopping and start to define what is 6G. So for instance, FR3 popping up. And I think the direction that I've seen so far in this ecosystem is very much in line with that. So we can enter the technicalities, but NTN is a big, big enabler because sustainability is another challenge. So as I mentioned, as Amritsu, we are really working with all the stakeholders. And again, I couldn't go too deep in this aspect, but I'm happy to elaborate. This is a very, let's say, high-level snapshot.
Thank you, Enrico. I mean, the topic of understanding how we really can contribute to 6G and the type of innovation that we will see there is still really a big question, and understanding really how you can shape those type of systems and how you can make them able to contribute to the business of the operators is another story, right?
Absolutely, absolutely. And again, I would stress out really the co-creation and collaboration. It's really key. Industry, academia, research partners. I think this is the key aspect, really.
Thank you. Antonio, right?
So hello everyone. So this is Antonio Marsico from NetReply. So just a few words what Reply is. So Reply Group is consultancy company focalized in several markets. Is a network of companies. Every company has got a specific specialization in a specific vertical. In our case, I'm part of NetReply, so it's the company that is expert in the consultancy and professional services for networks in general. So starting from also inputs that are coming from other system integrators and that work in the industry, we see in our customer the need of, in general, digitalization and simplification. So I will start from this concept that from some of you that work in the integration and also consultancy to the companies, to customers, is this something that is happening now is the loss of competencies on some of, for instance, testing of old systems that are still there and needs to be somehow upgraded. And for instance, we have got in our customers in the telco market, in particular, they are losing people that are retiring, and they are losing time in order to pass these competencies to the new colleagues. And the problem is you need to speed up the testing part of the systems with automation, with simplification, upgrading the systems to a new, let's say, technology. And this could be really complex, in particular in the telco market. And this is where happens, let's say, systems like digital twin. So as NetReply, we are working in the area of digital twin in the Coherent project. We entered with the cascade calls inside this project, and we think that the idea of digital twin can also help, let's say, to simplify the management of the network and how you can upgrade the network. It's a really complex matter. We see it in our project because digitalization of, we say, is not a real simulation of the digital twin. It's something else because you're going to add also orchestration logic, algorithms that can help you to simplify or to change the network patterns that you already have. So you need to test in advance inside the digital twin these new algorithms and then move these new logics inside the real network. And there comes the complexity. So digital twin can help, but at the same time, you need a way to simulate the functions in the network. So, this comes also the help of the vendor. So if we are, would say, brave enough to move this idea of digital twin to also vendors, and they see the added value of the digitalization of, and say, intelligent simulation of the system. And this can really help, let's say, on progressing the infrastructure, in particular in the telco market. And at the same time, take also from the speech from Unidata regarding also the utilities. Also, this is another market that we see. And utilities, they have got really huge, let's say, networks. Really like network operators. They also own fiber optic infrastructure. So they really have got really huge networks. And the problem is, if in the telco market, people are somehow skilled in the telecommunication in general, so it can be easier to do, also to discuss with the customer, because we talk more or less the same language. When you go to the utilities market, they see the network as a commodity. And you need to help them to understand how you can progress their network and integrate the digitalization of the data lakes, whatever is needed. So this is another point that I would like to underline. Thanks.
Thank you, Antonio. Federico, Smarty, small company really at the age of technology.
Yes, right.
So the innovation is everything for you. What can you say of what can the research community can contribute to your innovation?
Yes, thank you. Thank you for the presentation and for being here today. And good morning, everybody. So let me introduce Smarty as a company. Probably many of you don't know, since we are, as Antonio said, a small company. Smarty has been founded in 2019 with a clear vision, the future in connection. So we dream a world where humans, technologies, and the sensors, machines are integrated in the same ecosystem, where all these actors can interact in a seamless, faster, and easy manner. To embrace this vision, we are focusing on three main aspects: perception, connectivity, and intelligence. With perception, we are thinking about smart sensors that can perceive the reality of the world. With intelligence, what we want to do is to bring artificial intelligence algorithms to these sensors, to these devices, in order to allow them to being capable of understanding and interacting with the reality. And with connectivity, we want to close this loop. So we have perception, we have sensors, intelligent, and we want to give them an infrastructure, a communication infrastructure reliable enough to interact and communicate. So this is actually the aspects we are working on. And to really embrace this vision, we are developing, we are prototyping, and also we produced smart sensors, in particular smart cameras, equipped with artificial intelligence and a private 5G network for the connectivity aspects. And this is also why we are here in the Restart project. As also some of my the colleagues here said, the collaboration is a really important topic for us. Research is really important because we need to bring high quality, high innovation products to the market. And collaboration with other partners, with academias, with research entities, with universities as well is really important for us. Going back to the question of the innovation we are looking for, in this year there are many topics that has been discussed so far in this plenary, but actually want to focus on two main aspects. So one is non-terrestrial networks. SMARTY has been awarded in 2020 with a national plan for military research by the Ministry of Defense, where we needed to develop a 5G private infrastructure for tactical communication. Now that we have this 5G, this private 5G network for this scope, we want to bring it non-terrestrial networks to increase coverage area and to enable new use case scenarios. Non-terrestrial networks brings with it a lot of challenges. In particular, I'm thinking about, for example, the Doppler effect and the delay. So also in this case, the research part and the collaboration with the partners can be really important for us to address these topics. Another challenge, another topic that we are interested in is integrated access backhaul. So the idea is to create something like a mesh network behind the private 5G. No? So yesterday, if I remember correctly, this Grand Challenge 1 is discussed about the possibility of deploying drones equipped with 5G, private 5G connectivity. And I think that integrated access backhaul is really adherent to this scheme, to this challenge. No? Putting connection with this paradigm to extend in a mesh way the network is really hard, in my opinion, no? And in particular in that case from the radio point of view. So now we have software-defined radios that are, improves a lot the connectivity. But there are a lot of challenges. I'm thinking about in-band full duplex, for example, in the integrated access backhaul. This is another topic that for the radio part is really complex. So this is why we want to explore this domain as well. Let me just conclude with another point that for SMART is important, is more social, not technological, I would say. One of the key points probably of the Restart program is to relaunch, the Restart, no? This is the name, the telecommunication in Italy. In particular, also, I think in the interest of the new students, of the young people that want to embrace this world, no? We are really open to collaborate also in that case. So workshops, collaboration with university institutions for us is important to help the Restart program and also beyond the Restart to increase the interest around telecommunication in Italy.
Consider yourself enrolled already.
Okay.
Thank you. Roberto, radically different dimension of the company, right?
Yes, today I'm here in representation of Prismian, that is one of the big, probably the biggest multinational company in Italy, a manufacturing company that is dedicated to produce cable, not only energy cable, but also fiber optic cable. We are basically 12 billion company present in every country in the world. And in reality, we came from a long time ago, because we are basically the former Pirelli Cavi. So we are the oldest cable maker in the world. And starting from this company, especially in the last 10 years, moves from a cable maker to a solution provider. So today we not provide only cable, but we provide a complex solution that cover cable installation, cable laying in case of submarine cable, but also monitoring, maintenance, diagnosis, eventually replacement or upgrading. So we provide a complex number of different services. And in this same, I think is important the collaboration with the university, because obviously a company that is trying to move from a manufacturing company to a service company needs a lot of innovation that cover all different aspects of the company. In particular, today my hat is not only the hat of director of Prismian, but also I am CEO of EOS, that is a company that was born in 2012, starting from a patent that I wrote as a professor of this university, together with Costantino Giaconia and other colleagues. And this company was born exactly to be added to the main company to introduce additional products and services. We have introduced, for example, the optical sensing solutions. So basically we produce today as Prismian DTS, DAS, monitoring system for parcel discharge, different kind of monitoring system from home. We have a product that cover also the low voltage monitoring aspect. In particular, in this project, we have decided to work together with some university and inside the Restart program to develop a new solution to cover unlimited submarine optical cable. So in terms of possibility to measure temperature with DTS and acoustic sensing with DAS, because we have a patent of an optical amplifier that is able to enlarge the distance that can be covered with this kind of system. And we have presented the prototype to my CEO 3 weeks ago. So basically, we are in time with the Restart project. And this is, in my opinion, a big game changer, because in this moment, due to the political situation that we have around the world, the possibility to monitor real-time cable for telecommunication or cable for power transmission is very, very important. This is basically what we do and what we are doing with the help of the Restart project. And I think that this kind of collaboration are really very important, because it's a way to know other people, other company, other research group that works in something that is close to us. Thank you.
Thank you, Roberto. Very interesting. We have time for another quick round of questions. I don't know if there are questions from the audience. Otherwise, okay. Roberto, come here. Yeah. Yes. Your voice is strong enough. Net reply and Italtel mainly. Yes. Difficult. Yeah. Very interesting. Antonio, Maria Pia, you can start.
Oh, okay. Thank you for the question. So the idea behind your question, so the collaboration is the main. The collaboration is the main point between academia and the industry, and I think in this framework, so in the Restart framework, there is I think the first time, at least in my experience, that we see the possibility to have a strong collaboration, okay? Because in general, from my experience also that I had working on European projects and other, let's say, when I was more in the academia part, it was difficult to work together with the industries, okay? So maybe you ask help from an industry, for instance, because they have got a specific product, and you put the industry inside a consortium. But then what I saw is, okay, they've done some innovation, but then it was difficult to put it in the market. So the main problem that I see is to create a long-term collaboration. That's the point. Maybe Restart can be the first, let's say, step on this direction. This is my opinion on that.
Thank you. Yes. Another point, the investment in the European telco market. For example, BT, Swisscom, Telefonica are investing in quantum technology and also in other technology. I would like to know in Italian market the same direction. The market
situation for operators is different.
Yes, is different. This is a problem. This is an issue.
Thank you. Other questions? Otherwise, I have several for them. I mean, let me start with Enrico, maybe, and Federico, right? You mentioned, the direction of the evolution towards 6G. But honestly, one of the questions is if operators will have the money for 6G, and when the standardization is almost starting, someone is suggesting to keep it as simple as possible, as similar as possible to 5G, just for avoiding too big investments, right? In that case, we don't need much innovation, right? How do you see the evolution of these kind of technologies, and how can we really, are we really at the point in which there is not much to innovate and maybe we don't need generations anymore, or and we need some different approach to introducing innovation in a more continuous way than just considering 10 years cycle of generations?
Thanks a lot for the question. I mean, I think it's a very critical point for the whole ecosystem, I would say. So starting from the question that we heard from the audience, so the discipline, the multidisciplinarity, I think just to quick go back there and then I'll answer, we should map competencies where challenges are. So also thinking about the role of telecommunication in the future on the education side, I think this is a key point. To your question, I think yes. So technology is definitely an enabler, can be an enabler of innovation, but technology per se is not innovation, right?
Yes.
And that's what I was saying before. We are there where we need to enable, I don't know, automotive, manufacturing, healthcare, we heard utilities, right? And respect their adoption cycle. What we can do is, or the question that currently is being asked from multiple angles is, what can we do to accelerate that? Because obviously, as you said, operators are now with a big question mark, what should they do? And I think there should be intellectual honesty at all levels, starting from the standard, with the question that you just hinted. Does it still make sense to force a 10-year cycle in an ecosystem that currently it's clearly replying with a longer adoption cycle? I think we should focus on the process, not so much on the technology. There are some key technological breakthrough that still need to happen. Also we as Enrico, we are part of them. We are now focusing a lot as a test and measurement company on transforming the way we do business, how we do things, to enable, for instance, 5G, what we have today in the portfolio, can it be prolonged in terms of reducing the capex for our customers in a way that the investment they made with 5G is actually transferable to whatever 6G is going to be. So softwareization, virtualization of test instruments, also test as a service. All these things, again, these are coming from the test and measurement company. I think I can speak also for our competitors. These are enablers, and I think it's innovation in the end, but each element of the telecommunications ecosystem, I think, should think in this way. So it's a very valid point. I don't have the solution for the whole ecosystem, but I think at least I gave the perspective of the test.
The infrastructure itself is an enabler, and unfortunately we have been giving for granted that it's evolution. But now we are understanding that the money that is needed is no longer there, which is an issue, right? Because otherwise, if you don't ensure the evolution of the infrastructure, you may slow down other innovation in the verticals, right?
Exactly, absolutely.
Federico, also considering what you are doing, I mean, intelligence at the edge with the sensors, smart sensors, considering also the news on DeepSeek 3 days ago on the availability of smaller models, simpler models that can be computed. This is another interesting domain, right? Understanding if an innovation which is different from the big tech of AI can happen in the network and in a more distributed way, which could be, if 6G is supposed to be the first AI-based generation, could be one interesting point to understand if there is room for other innovators, not only the open AI and the big of AI.
Yeah, this is a really good question and point. For us, since we are working also with artificial intelligence, as said before, it's important to use this artificial intelligence also in the 5G, 6G networks. I'm thinking about, for example, orchestration of the RAN, or putting services on the RAN itself. No, we have, for instance, just for an example, we have a service dedicated for military applications that is able to filter out the malicious traffic. So it's something like, again, cyber attacks, cyber threats. So AI is important, is really important. But of course, we need to define, for instance, now this DeepSeek, OpenAI. There are a lot of companies that now is working on artificial intelligence. We really need AI also inside, in my opinion, 5G, 6G networks in the future, because there's a lot of application where they can be, they should be installed and used inside. Because that can unleash new services, new vision. We're talking about digital twins, we are talking about many other services that uses AI. Another point, however, is the control of the information. So we can now cover aspects like privacy, like where this data goes to. I'm quite sure that if I write something on DeepSeek, probably all the data goes to probably Chinese data center, as well as if I type something on ChatGPT, this goes to American data center. So probably, at least from our point of view, is how we handle the information, how we can guarantee the service and trust enough to preserve privacy, and also I would say not only privacy, but how to handle this data. So make it clear, okay? Make it clear how you use this data and how the AI works inside the network as well.
And probably also, if the task is not too complicated, keep everything local as an advantage also in terms of cost, not only in terms of privacy, right?
Yes, one of the aspects could be, for instance, using edge computing. So everything is local, is faster, and in this case, you are quite sure that the data remains locally, not going outside.
Thank you. Patrizio, you mentioned, that, the specific technology used for an utility, water utility, but there are also others, is not that important. But on the other side, the building on the digital layer created by the data is fundamental. However, in the domain of utilities, we have been been driven in the innovation by the new regulations for telemetering of all the meters and trying to save cost in terms of the meter reading. While the innovation for the end user is not really much there. How can we create new services for the end users?
Yes, thanks. This question is related to the question related to the collaboration between research and telecommunication company. In the past, the final result of a research project was the proof of concept. And my colleague defined the proof of business. This is the new level of collaboration between research and the telecommunication company. And the proof of business is the start of the research project. It means that the demand of innovation must be shared between the market and the research and the company, the research institute and the company. Yesterday we have a long meeting with AMAP Palermo. We won the tender for covering Palermo Città Metropolitana with the IoT network.
Oh, wow.
And now we can produce data from a lot of devices in Palermo. And we have a meeting together with AMAP, how we can transform this data in new service for you and for your customer. Because in the water utility, the customer is the final user and can monitor the use of the water. Just an example, like in the smart grid, power grid, I can monitor the use of the water in my life. We have a research related to the disaggregation of the water consumption in our home. I can have the feeling that I wasting the water in my cousin or in where I wasting the water in my home. It could be a link between the research and the final user service.
Thank you. Roberto, the business of cables and in particular fibers is, again coming, yes, and now coming back again with the big interest in the submarine cables and all the big companies that are, this is another geopolitical, domain already, and everybody's trying now to see how to deploy new cables, but also to understand how to make them smarter, able to detect if someone is trying to cut them, or so even the sensing part is becoming part of the equation, and probably you will not deploy submarine cables like they did 10 years ago, right? What kind of innovation can come from this, renewed interest in putting down long cables among different countries?
First of all, you are absolutely right, and then I would like to tell you a short story that is related to the fact that Pirelli sold the optical amplifier technology 10 years ago, 15 years ago to Cisco, because they were not interested in this kind of market, yes. And this market could be has been considered a dead market. Today we are going to develop internally a new technology for optic amplifier that cannot leverage on the patent that we have sold to Cisco, that now become a sort of our competitor.
These are the very successful strategic decisions.
Exactly. So, in any case, you are right. Due to the fact that the business of submarine cable is always going up and down with a period of 10, 15 years, the point is that obviously the business have to follow the market, and not the opposite. So at the end, we do what the market requires. The point is that to start to enter again in this market, you need not only the technology that is relatively easy to be in some way developed or acquired, but you need the capacity, because a factory to produce a submarine cable, it's not a small office. No, it's a big infrastructure, big investment, a lot of people that have to work there with the right knowledge. So the complexity is really huge. We are probably the bigger player in this market from the European countries. We are investing a lot in this market, but we, in some way, we have to cover the gap of this kind of mistake that Pirelli has done many years ago, before the born of Prisma, but in any case, it was a sort of mistake.
Thank you very much. So I think it was really a nice and interesting discussion. So let's thank our panelists again. Thank you. So, thank you. We move now to technical session number 3. Laura Galluccio will chair the session. And this session is between you and the lunch, so let's try to keep the time.
So, good morning, everybody. I'm Laura Galluccio. I'm Associate Professor at University of Catania. And today, I'm very happy to chair this session about industrial IoT and WLAN. I invite here to the 3 speakers. Gianpaolo Quozzo is here, so please come here. Giuseppe and Luca Davoli. Is there Luca Davoli? Okay. So, let's introduce our first speaker, Gianpaolo Quozzo. He got his PhD in 2023 from University of Bologna, and he is now a postdoc researcher in WLAB CNIT. So let's start his talk. Please consider that you have 20 minutes for your talk, so let's keep in 15 and 5 minutes for questions. So.
Okay, thank you very much for the kind introduction, and I'm very happy to be here today. I'm the obstacle to the lunch, so I'm trying to be as quick as possible. Today I'm going to show you an activity that is jointly assessing 5G and artificial intelligence for detection and preventions of liquid drop from autonomous mobile robots. So the presentation will be through these points where I will first clarify the framework where the activity has been generated. Then I will describe the case study in detail and the proposed solutions. And then I will propose you both theoretical and experimental results spreading out from this topic. And then I will draw conclusions and show you some next steps. So let's start from the framework then. The activity has been carried out within the IN project, Industrial Network Project, which is led by Professor Roberto Verdone, and I'm the deputy PI of the project. And quite recently, actually, the project has also involved the tap-in cascade call, which is led by Professor Andrea Conti. And at the moment, the consortium has 7 universities, 2 R&D centers, and 6 companies, which are working all together for a unique objective, which is to identify innovative ICT solutions for industrial applications, with both a medium and long-term perspective. In particular, we are carrying out 36 activities overall, and we target 7 proof of concepts, where one out of these 7 POC is the one I'm going to show you today. So let's go into the detail of the industrial case study for this POC. So we are talking about autonomous mobile robots, which means robots that can move from one point to another one according to moving thanks to their laser systems. Typically in industrial environments, these kind of robots are used for 3 main application domains. The first one is for logistic purposes, or they are used for assembly lines. But most often they are used in order to carry liquids from one place to another one, for example, in warehouses. And this is actually the application domain that our solution is targeting. So in detail, actually the problem that we are trying to address is the coexistence of humans and robots within an industrial environment, where basically what it may happen that when the robot is moving and there is a human, a worker, which is crossing by its path, then it might cause some blockage or some change in the path that can happen very quick. And since typically there are no mechanical constraints that can avoid the flow of the liquid, then this can cause the liquid drop. And typically these liquids are dangerous. So our application is mostly related to the safety issues within industrial environments. And this is actually, in our perspective, a problem which is also showed here, because I've tried to manipulate a little bit the data provided by the annual report of the National Institute for Assurance regarding to injuries in working environment. And as you can see, basically in 2023, the injuries within industrial environments are one of the most common and aspects and most critical ones, as you can see. Of course, this data does not mean that all the injuries refer to our specific application, but for sure, this is a point of attention that we are trying to address with our solution. So let's talk about what we have done there in order to solve this issue. So our idea was the following. So basically, what we have done is to connect in 5G the robot, and so that to collect in real time data regarding the movement of the robot. And these data are stored and processed to a local edge cloud. There are also some artificial intelligence algorithms that aim to actually predict, based on the current data, some sudden liquid drop from the robot. And if some predictions are made about this phenomenon, then some actuation command can be sent still via 5G in order to avoid this kind of liquid fall. And we have also created a mechanical grip that makes the actuation. So this is the general idea. In order to realize this, we have gone through different number of steps that are represented here. And you see in green the steps that more experimental activities, and in orange the one which are mostly theoretical. So first of all, we have defined the POC setup, which means that we have interconnected in 5G the robot, and then we have set up the server, and then we have created the mechanical gripper, and so on and so forth. Then when the POC, the baseline for the POC was ready, then we have made some measurement campaign in order to obtain the data. And then, of course, the data has been processed in order to create data set for training of AI algorithms and also for their testing. And finally, we have made the full testing in a real industrial environment in order to see whether or not this solution may work. So in detail, this is what we have done. So we have considered as autonomous mobile robot the one provided by the BIREX ecosystem, which is one of the 8 Italian competence centers for Industry 4.0, because YLab has a memorandum of understanding with them. And so what we have done, as you can see, is that we have mounted on them a 5G board and a motion sensor, which is actually collecting the data. And then also our homemade gripper. And both the board and the gripper has as a common power supply a power bank, as you can see. And then the network is there available at BIREX, so it is a private 5G network. You see the RAN and you see the core network, and then the server is located within it. And so with this setup, we are able to collect the data, so the orange line, and also send the actuation, the green one. So this was, as I said, the first step. So so what we have done, as I said, is to basically, I'm trying to, because the animation is not working. Okay, so as a second step, we have made the measurement campaign, as I said. So you see here that we have collected some data. Specifically, on the left, we have you can see the acceleration on the y-axis and x-axis that are collected in real time, as you can see, and also some angular velocity thanks to the fact that the motion sensor has also a gyroscope. On the right, instead, you see that we are also collecting the orientation of the robot with respect to its axis, and also the position in real time, so the path that it is traveling. These are the kind of data that we have collected in step 2 of our chain, and then we have made some analysis on the data that we have collected in order to make the problem formulation. So here you can see an example where we have the blue curve, the acceleration on the x-axis within a given path, and then there is also the position on the y-axis, and then you see a red dot when there have been anomalies, which means that the liquid has fall from the robot. So the analysis that we have done is to understand what can be done in order to make a prediction about the possible dangerous situation. And as you can see, if the most simple approach would have been to set a threshold, right? So if the acceleration goes beyond the threshold, then the system can say, okay, there will be a problem or not. But if we apply such an algorithm, then as it can be seen here, then this kind of mechanism would fail 3 times over 4, because actually we have 4 peaks, but there were just 1 dangerous situation. That's why we thought to create something a little bit more elaborated, complicated, and so the idea was to formulate the problem as a binary prediction task, because our algorithm should perform a binary prediction, fault or not fault, given a sample of motion data, and then it is predictive because it has to do so before actually that the event, the dangerous event would happen. So since we have made this kind of problem formulation, then we had to elaborate the data in order to obtain something that can be used to create our solution. So first of all, we have made a class weighting, because even though we have made a lot of measurement campaign, clearly, then the fault data are much less than the known fault. So the data set were skewed. And so we have applied a class weighting operation. Then we have created other features. Specifically, we have defined fixed length windows that moves along our data set in order to compute the maximum, minimum, mean, and standard deviation along this window. Then we applied differencing, which is a technique typically used to remove seasonality in the data, which means subtracting to the given sample the mean value. Then we have standardized the data in order to have the same dynamicity, so the same scale. And then we have subdivided the whole data set into time series, where a time series represents all the motion data from the moment from which the robot has started its path, according to when there have been a dangerous situation, which means that the liquid has created a drop. And so we have obtained this time series. This is the final results, so just a glimpse on that. And we have clearly divided the time series for training, validation, and testing, because then we have decided to apply AI in order to solve the binary prediction task. So let's jump to the results then. First, from the theoretical perspective. What we have done in the paper that you can find there in the QR code is that we have compared 7 deep learning algorithms with respect to a baseline approach. The baseline approach is the threshold-based mechanism that I was showing you before. And these are the rows. Instead, regarding the columns, you can find, first of all, a parameter which we have called margin, which represents the number of time series samples prior to a fault event. So basically, it means that if we enlarge the margin, it means that we are training the algorithm to foresee for a longer time period, but at the same time, we'll lose in accuracy. And the term accuracy, we have defined it with 2 KPIs. Which are the other two columns that you can see for each margin. The first is the cost. So we have defined a function that is a typical approach in machine learning, where basically we have to provide a penalty when actually the prediction is not the right one. Since we are targeting safety in industrial environment, in our case, we have defined a higher cost to false negative. So when the algorithm says, okay, it will not fall, when actually it does. And then considering both false positive and false negative, we have made our cost function. And then we have the mean advance function, which means the mean over the time series, amount of time before the actual fault event occurs. So basically, when we enlarge the margin, both the cost and the mean advance function increases, which means we foresee for a longer period, but we are less accurate, and the accuracy is quantified by the cost. According to this comparison, you see that basically the best algorithm is, in our case, was the convolutional neural network. That is the one that we have considered then for further analysis. An example is represented here, just considering the best algorithm and considering a margin of 7. You see the acceleration, the x-axis as a function of time, and then we have inserted the predicted fault instant and the true fault. As you can see, the predicted fault, the yellow line, happens clearly before the real dangerous event, which is demonstrated by the fact that the acceleration has a down peak. In particular, this difference is roughly 40 samples. Since we are obtaining data from the motion sensor with a periodicity of 10 milliseconds, this means that it is an anticipation of 400 milliseconds. That is compatible with the overall delay budget, which means the delay introduced by the 5G network, the delay introduced by the AI inference, and the delay introduced by the gripper, which has been experimentally measured as 300 milliseconds. So from the theory perspective, we were hoping that actually this could work in practice. And this is what we have done in the end. That is, you see here the result, the experimental results. So on the left, it is the case where actually the algorithm was not active. So basically, there is a sudden interruption of its path, and then actually the liquid fall. And of course, for our experiments, we were just considering a bottle of water. On the right-hand side, instead, you see what happens when we have applied all the system that I have explained. So basically, the data are processed at the server, so are sent via 5G, processed by the server, then our CNN works on the data, makes the prediction, and then is sent back to the robot. And then actually, our homemade gripper is able to close, to apply the actuation and avoid the fall. So this is the experimental results. So let's draw conclusions then from our work. First of all, what we have done basically can be summarized in 2 points in my view. First, we have identified what we believe it is an industry relevant use case, because we are talking about safety. And then we have worked on an end-to-end pipeline, both from the theoretical perspective and experimental one. But there are a lot of next steps that we are working on and we would like to investigate. And I've divided that in three categories. The first one is optimization. So what we can do more for the given algorithm. First, generalization, because actually we have worked with one path, one robot. So of course we would increase the number of possible paths and also number of possible robots. Then network monitoring, because as you have seen, we have we are basing our solution with a very simple data, which is related to the motion of the robot. But we can also increase the accuracy of the model by analyzing what the network is doing, so working on network KPIs. And then also, we can enlarge the TRL because we are working with a very simple and cheap sensor, but we can have more precise sensors and more than one sensor. And also we can have also a faster gripper because it takes something like 200 milliseconds just to make the actuation that in this application is a very long time period. As additional feature, instead, we can also, more from the communication perspective, we can also integrate the AI prediction with localization data, because if the network is able also to recreate the map of the environment, then of course we can leverage this information in order to make more localized informed decisions on the possible prediction of fault. And finally, we are contributing to the Restart program, in particular to the Grand Challenge 4 on Network Digital Twin, because basically this Grand Challenge is now considering this use case as the first use case on which built the network digital twin. So actually we are interacting with the group work in order to explain what we have done. So that was actually the end of my presentation, so I'm willing to hear for some questions.
Okay, so thanks Gianpaolo. Are there any questions? We have time for one quick question. No? I have two comments. One is about let's say at the very beginning of your presentation, you correctly highlighted the impact of this type of activities in terms of prevention of, small accidents, especially in the manufacturing field. So in Italy, we know that there is this huge emergence for prevention, especially in building operations. So in the long term, let's say that this collaboration of a network of AMR can help maybe to prevent this. Another one is more like a technical feature. So you highlighted that you used indeed convolutional neural networks to, in the end, do this prediction and classification. Did you consider, or are you considering the possibility to, let's say, have a system that learns, so uses kind of LLM solutions to try to learn what is happening at runtime, and then maybe not stopping but modifying some parameters like the speed of the movement or the direction in such a way to avoid that some accidents happen?
Okay, so thank you for the question. So regarding the first one, I got it is more related to the application domain. So basically, yes, we believe that safety is one of the use cases according to which all the industries are interested to. But there is one specific constraint for them, is that they do not want to add anything, so they do not want to mount something. So they would like to have their environment, then they would like to have the wireless ecosystem or ICT solutions that run on top of that. That's why, yeah, we have inserted our devices as a first demo, but our idea is actually to work on the network side in order to enhance basically the safety by considering all the different the specific application that are targeting there. So my message is that it is very important, but at the same time we should be able, and this is what the project is saying is doing by talking with the industry, to be as less invasive as possible. So that's as an answer for the first question. The second question, the answer is that we have not investigated something that learns in a continuous way, let's say, but it is very interesting. And for example, LLM is one option clearly, but most generally we can apply reinforcement learning. These were deep learning model just. But if we use some tools such that they have a given task and they try to learn as long as something happened, this would be beneficial. The problem is that it's very likely that the complexity will grow a lot because there are a lot of variables within it. So this can be tested, in our opinion, in a controlled environment due to the fact that there can be different machines, humans, as I said, and whatever. But for sure, this is the long-term vision because they, as I've said for the first answer, they don't want to tune everything. So it should be a system that autonomously adapt and does not need to install something new or modify their environment.
Okay, so thanks again, Gianpaolo, and let's move to our second speaker, who is Luca Davoli. Luca is assistant professor at University of Parma, and Luca will talk about multi-interface gateway with embedded intelligence.
Yep. Thank you so much. First of all, sorry for not being compliant with the template of the presentation, but I was not really aware of the fact that there would be one, so I'll try to resume in this way. So first of all, these are the main points that we will see in this hopefully brief presentation, so which is our involvement inside the Restart project. What is, really briefly, the IoT, the objective of our research, the functionalities of this multi-interface gateway, In the end, it's internal routing mechanism and a bit of, how to say, suggestion on how to embed intelligence inside the MIGate, and then which would be the deployment inside industrial scenarios, so in the end inside a proof of concept where we are involved in. So thank you once more also, Gianpaolo, for introducing the tapping project, because we are one of the 7 partners included in this, involved in this Cascade Call project. We are mainly involved in the work package number 4B, and in the end the work package 7 if we rely on the naming of the tapping project. And so our main objective is to try to define an architecture to be applied to industrial scenarios, and to try to design embedded intelligence solutions and strategies trying to optimize the performance that the systems would have. So mainly I think that you may know what the IoT is, and in this case, since we would like to apply the IoT to industrial scenarios, maybe the core aspect in this case would be the need to exchange data between often heterogeneous devices, and hopefully using heterogeneous communication protocols. So in this case, the main point, the main device in this way, I would say, that would adapt to these needs would be a gateway. But yeah, we have a lot of commercial gateways that arise in the market, that are still present in the market, and obviously that has been defined for being able to perform various workloads and tasks. So in general, these commercial gateways, they are designed in order to collect data and to forward them to their private cloud. So what it might happen is that on the overall, all these commercial solutions, they are pretty vertical, so they are pretty closed. And as well, the other main drawbacks from my personal point of view is that these commercial gateways are a bit fixed, and so they cannot be extended afterwards. Okay, so if you want to try to improve the functionalities, to improve the performance, and to improve the capabilities that we would like to exploit inside our industrial network, maybe this won't be the right solution. So there might exist some alternatives that in this case would rely on the definition of a customized gateway. So in the end, what we are trying to do inside the tapping project is to define a relatively low-cost solution, and then we will see as of today, which is the prototypical solution that we define, that would be scalable enough in order to be able to include additional network interfaces and communication protocols on the basis of the needs. And then at this point, we are trying to focus on on a fully customizable internal routing solution that would allow us to define some processing rules and some routing rules, allowing us to define how the traffic should be steered inside the MIGate and among all the network interfaces. And then obviously a sort of management dashboard that would be useful to manage all the functionalities. So as I said previously, right now the prototypical solution foresees a Raspberry Pi as a processing board, and the Pi embeds as native interfaces, a BLE interfaces and a BLE interface, and the Wi-Fi 1. Then since we would like to act both as an access point and also as a Wi-Fi client, we included an additional Wi-Fi dongle and the same holds for the BLE functionalities. So if you want to perform both as smart master and slaves, or central and peripheral, just to be compliant with the new naming, we included as well an additional BLE interface. And then since we would like also to try to include I would call it as a new protocol. In the end, it's not so new, but it's we saw that it might be really expedient in several scenarios. We also included 2 additional LoRaWAN interfaces. One that should act as a gateway, and to this end, it will be integrated with a network server and an application server, and the other interface would act as an end node module. So the overall, the conjunction of these interfaces would allow, in the end, all these flows, okay? And this means that, for example, we might have if we look and if we focus on the BLE interface, we might have an external device that would connect to us as a miGate because we are advertising some GATT characteristics. Another flow might be, in this case, if we process a data internally and then we would like to send it to the cloud or to a remote system, and in this way we will use our Wi-Fi client interface, and then there would exist all the other flows. So for example, if we want to collect data from a pre-deployed LoRaWAN node, then we will allow this external end node to connect to our gateway interface, and then I would say, quite last but not least, we will allow an internal processing, because in the end data should be processed enough in order to allow a sort of data aggregation or any kind of processing that you'd like to do inside the miGate. So these are mainly the main software technologies that we are using right now. So you might recognize Python as a programming language that is right now one of the most powerful ones, and all other libraries that allows us to use all these communication interfaces. Then, instead of using MQTT, that is a worldwide known publish-subscribe protocol, we decided to shift to another similar one that is called Zeno. Is as well a publish-subscribe protocol, but in the end it's pretty similar also to the HTTP protocol. It's fast and lightweight, and so we are facing not so many difficulties and drawbacks in using it, because in the end, if we have to define how data traffic will be let available to one interface from another one, the things that we have to do is to define a subscriber and the publisher, these two entities for each interface that we would like to use inside the miGate, and then this will be maybe all we have to do. So before I mention also the fact that inside internally the miGate we have this routing mechanism. It is based mainly on the definition of JSON-based rules, where we can define an ID, the source and the destination addresses and interfaces, and the same holds for the processing rules. This means that we can build a sort of chain in a service function chain way. We can build this kind of chain of processing, okay, where we can process the data. And so this, the last thing that I'd like to show you is this web-based dashboard that allows us to simply define and manage all these rules, all this information, okay, so relying both on routing and processing. And then last but not least, really, in this case, with regard to the embedding the intelligence, since we are involved and we will work together with the company inside the tapping project that is NIVA, that today wasn't able to be here. And right now they are manufacturing industrial machinery to be used in the textile industry. We would like to embed a bit of intelligence inside our miGate. So one possible solution might be, for example, to try to exploit the federated learning. So maybe you know better than me what federated learning is. It mainly requires to train locally a model and then to send only the model, not all the raw data that you use in order to train locally the model. You should send this model toward a sort of remote system that in the end will aggregate all the models, and then it will send back to you the revised and updated model. So what we will do, what we are studying, what we are analyzing right now is how to for example, as in this case, collect information, collect data from an industrial machinery, like the one that I mentioned you before, manufactured by NIVA, and all this operation might be useful and might be done also with other systems, but since LoRaWAN is not supported by the majority of the systems, and since we would like to provide a sort of backup solution in the case that, for example, Wi-Fi connectivity, cellular connectivity, all the well-known connectivities, they would be not available. In this case, maybe the MiGate might be really expedient in order to provide this sort of backup solution, okay? Maybe only to send an alert, maybe only to send a warning, but this might be enough, as we understood from the industrial partner, in order to suggest and in order to notify that something is happening. Just to conclude, we focused on, and we are focusing right now on the development of enhanced prototypical versions of the MiGate. We would like to include also some additional algorithms like an RB algorithm to test and to verify that all the functionalities, they are working properly. And obviously, we would also try to include additional network interfaces like cellular ones, 5G, and so on, and also try to evaluate different traffic classification models just to test their performance, also to understand if the processing board that we choose would be enough or if we should shift to something else. So obviously with this I thank you once more for the attention and I leave the floor for questions.
We thank Luca. Also we have time for a couple of quick questions. Other questions? I have two from my side. One is when you designed this gateway, were you thinking about a specific application need that maybe emerged from companies? So are you focusing on something which is very, very critical to be addressed and that where the traditional, let's say, commercial gateway cannot be so efficient? And the second one is more related to the routing choices that you were highlighting. What about these routing choices? Are they driven only traditionally using ports and IP, or is there kind of software-defined methodology that can be used? So based, for example, on the content of the packet to choose where to address, or kind of equalization among the load?
Okay, so thanks for this really interesting question. So just to reply to the first one, in this specific case, we focus on the need to be able to provide a backup solution, as I said before, exploiting a protocol that in general is not used anymore in the industrial scenario, because LoRaWAN in general is used for outdoor scenarios, for example, for smart agriculture and similars, or smart cities, for example. But in the case that an industrial machinery is not able to exploit due to a connection drawback, to send a, I would say, even not critical information, not critical alert, or as well if you want simply to send an heartbeat information just to state, okay, I'm alive, I'm working properly, I have no problem. We were asked maybe to the possibility to be able to send this simple information, this constrained information, and maybe this try to reply to the first question. With regard to the second one, yeah, we would use a match between IP and ports to route the information, the traffic internally to the MiGate, but then we will also try to include an ICN base, for example, system maybe based on content, maybe based on specific interest. This would be an interesting add-on and an interesting possibility to be provided also, and that might open also to additional scenarios, because, for example, the MiGate, we will try to apply it also to vehicular scenarios, for example, and in that case, if we shift to vehicle flowing inside a city, then in that case, LoRaWAN would be maybe better suited to design, in that case, the intent and the interest would be maybe a way to better define and to better match the traffic to be sent. So yeah, we will study all these systems. So thanks again.
Okay, so thanks again, Luca, and let's move to the last speech in this session. We don't want to miss lunch. So let's welcome Giuseppe. There are a lot of things to say about Giuseppe, but we want to be very short. He is a full professor at University of Pisa, and he will talk about a framework for optimal resource allocation in the cloud to things continuum for industrial applications with mobile nodes. So please.
Okay, thank you, Laura, for your kind introduction. Okay, so as you can see, the goal of this presentation is JNECORA. That is an analytical tool that can be used in the design phase of an industrial IoT network for defining the optimal joint allocation of both network and computing resources along the cloud to thing continuum. Okay. Okay, so this is the overview. I will give some motivation for our work, then I will show the system model, then I will present the tool and some performance results, and finally I will conclude. This activity has been carried out in the framework of the PESCO project. Okay, so this is the reference scenario. We consider an industrial IoT network where there are a number of mobile nodes. They may be mobile robots or autonomous vehicles. The first speaker has already presented a number of potential applications in this industrial scenario. We do not make any assumption about the communication, the wireless technology that is used. It may be 5G, for instance, or it may be TISH or Wi-Fi or any other communication technology. Okay, the assumption instead is that mobile nodes use computing resources that are available on the cloud to edge to things continuum. So some of these computational resources may be available, for instance, at edge nodes that corresponds to border routers or access points or the base station. Some other computational resources instead are available in the cloud. So this scenario is characterized by a large heterogeneity. Heterogeneity not only in terms of IoT devices that may be very different, and not only in terms of communication technologies that may be also different, but also in terms of computing resources that may be available in edge nodes or even in the cloud, and even edge nodes may be different in terms of computational resources. But finally, there is also heterogeneity in terms of applications, in the sense that the same system should be able to support many different applications, okay, with different quality of service requirements. So there are a number of challenges that must be addressed when dealing with this scenario. First of all, stringent quality of service requirements in terms of maximum delay that can be tolerated by the application, minimum reliability that must be guaranteed to the application, even in terms of security and energy efficiency, but security and energy efficiency have not been considered in this work. Also, node mobility adds some complexity to the problem. And finally, there is system reconfigurability. It means that new applications can dynamically join and add it to the set of current applications, or the quality of service may change over time, increasing, for instance, the requirements. New mobile nodes can join the system and so on and so forth. Okay, in terms of quality of service requirements, the Industrial Society for Automation has defined different classes of industrial applications with different requirements in terms of delay and reliability. So we have emergency applications, for instance, with very, very stringent delay and reliability requirements. And then, of course, there are other industrial applications where the requirements are more relaxed. So there is a gamma of different applications with different requirements. Okay, so the basic question is how to allocate computing and communication resources in the cloud to thing continuum to guarantee the quality of service in terms of maximum delay, minimum latency, even in the presence of node mobility. Okay, so we assumed the periodic applications, and we didn't consider system reconfiguration, which means that applications are static, or the set of applications is statically defined at the design time. Okay, and so the result of our work was JNECORA, that is an analytical tool for optimal resource allocation based on probabilistic models of network links and computing nodes. This tool provides probabilistic bounds on the quality of service that can be experienced by a mobile IoT node. And so it allows the side zinc of the system so that it can be possible to guarantee the more or less stringent requirements of the application. And this tool is quite flexible and can be customized to different use cases. So you can customize it to different use cases. So for us, an application corresponds to a process or a task that must be executed on a cloud or edge node. And then we characterize network links through the probability density function of the delay introduced by that link. And we characterize the computing nodes through the probability density function of the execution time and also the queuing time, assuming that some queuing delay can be experienced in that computing nodes. So if we are able to model links and computing nodes with an appropriate model, okay, we can investigate the maximum delay experienced by each transaction. Every time a mobile node generates a data, this triggers a transaction that corresponds to an exchange of messages between the mobile nodes and a cloud or edge node where the corresponding task will be executed. So we can, if we have defined the model, communication model or computational model or queuing model, we can easily calculate the overall delay experienced by a transaction, for instance, a unidirectional or a bidirectional transaction. And so we can formulate an optimization problem, okay? So we assume to know the maximum delay that can be tolerated by the process, the minimum delay, the minimum reliability, the minimum fraction of transactions that must be completed on time for each process, for a set of processes. And of course, if we know the set of available edge and cloud nodes, we can formulate this optimization problem, okay, that minimizes, that find out an optimal solution in the sense that a solution that is able to satisfy the application requirements. The result of this solution is the allocation matrix, okay, that provides the node where the task must be executed. And also the maximum number of mobile nodes that can be supported while satisfying the application requirements. In some cases, an optimal solution may not exist, okay, so the tool provides a best effort solution, okay, a solution that minimizes the distance between the required delay, for instance, and the delay that can be guaranteed. And again, the result is the allocation matrix. Okay, so of course, this is a very general tool that can be used in different use cases, so it can be customized to different scenarios, okay? In order to validate it, we considered the specific use case. So we assumed that the communication between mobile nodes and border router or access point is through TISH, so short-range wireless communication. Okay, but for this specific use case, because TISH is very popular in industrial settings. We also assumed that border routers communicate with the gateway through Ethernet links, dedicated Ethernet links, and finally the gateway will communicate to the cloud node using a cloud network, let's say. We characterized the delay in all of these links using either an analytical approach for TISH conditions, measurements for dedicated Ethernet links, and a data set that is already available in the literature for modeling the communication between the gateway node and the cloud. So 3 different approaches this means that it is possible to use any approach in order to characterize the link model or the computation model at the cloud. Okay, we considered a set of processes with corresponding requirements in terms of maximum delay and minimum reliability. The values considered in this validation are not very stringent because, of course, we need to compare these values with simulation results. So, okay, they cannot be very stringent, but in principle, the analytical tool can consider also very stringent values, very stringent requirements. Okay, we considered the 3 different industrial scenarios and 3 different mobility patterns. For instance, in the first scenario, mobile robots are assumed to move linearly. In the second scenario, they are assumed to move randomly. In the third scenario, there are some nodes that move linearly, others that move randomly. Each scenario is a rectangular area, including walls and also obstacles. And the deployment of border router or access points have been calculated according to a genetic algorithm that was investigated in a previous paper, and it allows the complete coverage of the area. Okay, so these are some of the results obtained. Here is a comparison between the maximum number of mobile nodes that is possible to accommodate according to the analytical tool and according to simulation. As you can see, the results are very similar. Sometimes there are some discrepancies. This is due to the fact that simulation and analytical curves typically are very close to each other, but of course there may be some differences, and in some cases this results in some different number of mobile nodes that can be supported for that specific scenario. Okay. In the paper that I will show in the end of my presentation, there are all the details. Of course, I cannot have enough time to show, to discuss, to present all the details. We also compared our approach with other similar approach available in the literature that make different assumptions about where computational resources are located. For instance, JPORA assumes that all the resources are available on edge nodes. There is no cloud in JPORA. No, resources are not available on the cloud. And GW instead assumes that there are computational resources at the edge and also at the cloud, but in the case of the edge, all the computational resources are concentrated in a single edge node instead of distribution. Okay. And again, we compared the results in the provided by the 3 different solutions. Okay, in the considered scenarios, our tool provides the better performance. Okay, there are other results in the paper. So in case you are interested, you can look at this paper that has been recently accepted for publication in the IEEE Internet of Things journal. We submitted the final version a couple of days ago, so according to the policy of the journal, it should be available in the next week or something like that. Okay, currently we are addressing the problem of dynamic allocation of resources because this tool is useful at the design time, okay, in order to derive the optimal allocation of resources. But of course, it may happen that new applications wants to join the system, or some new mobile nodes wants to join the system, or some application needs to increase their requirements. Okay, so we need to address also the dynamic management of the system. Also, we plan to implement this tool and the dynamic version in a real system. And yesterday we discussed it with Luca Foschini to use the testbed available at BREX. Another possible planned activity is to consider different wireless technologies instead of only TISH. So for instance, 5G or Wi-Fi or any other communication technology in order to compare different alternative solutions if possible. Okay, this concludes my presentation.
So we thank Giuseppe, our last speaker. Are there questions, comments for Giuseppe? Giuseppe, a couple of comments from my side. First comment, if I correctly understood, your allocation is done for each task. Is there a possibility to somehow allocate resources based on a sequence of tasks that you want to perform in such a way that you don't go, let's say, for the maximum and the minimum among the tasks, but something that is kind of chaining of the tasks? And the other question is, you were correctly highlighting the fact that you should now focus on dynamic allocation of resources, because this approach is done centralized, right? According to my understanding. So yes, there are in principle not a lot of constraints about, the complexity, because I guess, is it a heuristic-based solution, or do you, you were to...
Okay. So regarding the first question, yes, it is possible to consider a chaining of invocations, for instance, a chain of functions invocation in a function as a service environment, for instance. Okay, it is possible. You have, of course, to change a little bit the model and the optimization problem, but I think it's feasible. Okay, regarding the second question, okay, it is a centralized approach. Okay, so everything, now we are operating at the same time. So the optimal allocation is calculated offline, all right? It may be calculated offline, okay? So this is not a problem. But even in the dynamic management, okay, the approach is centralized. So the gateway or network coordinator is assumed to have full control of the system, okay? This is a typical approach that is used in industrial systems because, of course, the centralized approach may not be the most efficient one in some sense, but it has the advantage that everything is under the control of the gateway node. Okay, because of course, in industrial systems, especially if requirements are very stringent, of course, you have to have everything under control.
Okay. So thanks again, our speakers. We are perfectly on time, so let's move to the lunch.
Quick announcement. I just want to remind you that we have the opportunity for voting for the poster and demos. So we will be opening the poll at 2 p.m. and it will remain open until 3:30. So be sure to vote for your preferred posters and demos, and then at the end we will have a little awarding ceremony. Thank you. Bravissimi.